I think that's how you make computers go. Good evening, everyone, and welcome to EGA Garden States Webcast. We are broadcasting tonight from a new location. We're testing things out a little bit. We're testing some things out because in the future we would like to be able to invite you along, so that we can actually spend these times together in person, and then we can actually get to know each other face to face, and have smoother Q&As, that sort of thing. So we're doing some testing tonight, so you might have to bear with us, but hopefully not too much. Hopefully we've done a bit lots of bits and pieces, so I think it's looking pretty good. And not just us doing these bits and pieces here, but the EGA team have been hard at work on all sorts of projects. If you haven't already, best place to keep up to date is the newsletter, entheogenesis.org. I'll get somebody who's in the YouTube comment section to drop it in there, but click on that, head to subscribe, and subscribe. You'll get all the updates, but I'll tell you a couple of recent ones now. If you're not also subscribed to the YouTube channel, subscribe there. There's a couple of new videos up, including one on the death cap. Look, I'm going to butcher any names if I try them. We've got Caine here, so he can pronounce it later. But that one came out just this week to help you identify the kinds of mushrooms you don't want to be picking, and the kinds of mushrooms that are most often ending up in the news for their, right there in the name is the potential result. Doesn't always happen. It might just be a hospitalization, but it's never a fun time. And you want to know, if you're not going to have a fun time, not to eat that mushroom. But most people are looking for a delicious time with the mushrooms that put them in strife. We've also got an article, EGA publishing on WLP. I love when we've got little small, like that, something's, I don't know what the WLP stands for, and I'll have to go and click buttons to find that out tonight. But Simon Beck, it's from Simon Beck, and Simon's also with us tonight. So luckily we have lots of people with answers to the questions that I'm asking myself, and we'll be able to answer those questions, and they might even be getting answered in the comment section right now, because this is live. You can ask your questions in the comment section. We do have moderators there on YouTube, on the YouTube channel, who are watching and waiting, and we will be able to answer those questions. There might even be other community members who might have some answers to a different kind of question or a more obscure question. I don't know. It's a broad community, and the more that you talk, the more that you'll get to know each other and find out who has these answers. Geez, I'm really close. Hi. I've got a different camera for later, but that's a vehicle mileage test, right? WLP, says Graham. Welcome, Anthony. That's not WLP. I know you're not getting at that, but I just saw the W, and that's where my mind went. Thanks, everyone, for getting those chats going, and hello to everyone. If you want to drop in what lands you're from, because I would like to acknowledge that we're broadcasting tonight from the lands of the Wurundjeri people of the Kulin Nation, and I'd like to pay our respects to the elders past and present, and the centuries, millennia of work that the original humans of this landscape have, all that work that they've done in keeping this landscape the way that it is, and nurturing it into the way that they would like to see it as well. And I hope that we can move back towards that kind of landscape, perhaps when these cities are broken. They're already broken, so not that cities are inherently bad, but we also have a new Carpi article, speaking beyond ayahuasca. Yeah. This is one you might have seen. There was a video up recently. I did a little bit of garden time activities with Nick, and this Yage. There's a few different pronunciations I could go with. Not sure. I'll ask for confirmation later from some others. Yage varieties and their names, and Carpi are a publisher. I can see reactions on all the cameras. Is it Caine? If you've got something for me, I can see you and hear you. So you can let me know if I'm getting pronunciations right. That's what we're here for. We're here to help me learn new words and how to say them right out loud. Because if they're just in my head, I don't know. One of the things as well, and we do have this here. We might be able to whip it out later. is the entheogen combination matrix. We've been taking it along to events over the summer festival season because we are broadcasting tonight from and want to give our thanks to Harm Reduction Victoria and the Dancewise program, who have been taking that entheogen combination matrix along to some events and have sparked some really good conversations. I've had some excellent conversations with some people who identified themselves as interested in plants but having no green thumbs. So you had some good talks about I don't know, little tips. Water your plants. It's a hot day. Some people forget. That's number one. Make sure to join the email list again. That's where I'm going to end on and pass over to our first speaker tonight. That email list is at the EGA website. Subscribe. That's where you get all the updates. That's the best place to go. We have lots on tonight, and we are going to get straight to that. Let's start that once more. So it is episode 24 of the webcast. Cubensis Rising, History, Diversity, ID, Info, Safety, and Research Updates. And I think this is our third one that we have had with Alistair, and about 37th with Caine, I think. I'm not keeping count. How many? Not just webcasts, I'm including all the little videos now. We've got quite the collection building. So for all you Caine lovers out there, we've got quite, we'll have a bit of that tonight. A bit of Alistair too. So, you know, let's keep it spicy. Tonight, all things Psilocybe cubensis. Sorry, in here I've got, thanks to our regular host, Nick Wallis. That's me. Hi, I'm Nick, by the way. Hi. Thank you to me. I don't need to do that. Psilocybe cubensis is a dung-loving fungus, and it is more for our northern friends, not something that we generally find growing here in Victoria. It is sometimes referred to as cubes. I have no idea. When people ask me about blue meanies, and I assume gold tops are your subaruginosa, but a blue meanies like cubes? Is that what people are generally, like, it's American talk? I don't know. Is it, because people just say it for any mushroom. Like, I had somebody once bring a mushroom that was just bright blue. I was like, is this blue meanie? I'm like, you should wash your hands after handling that. So, I don't know what that is. Psilocybe cubensis is considered a relatively easy-to-forage mushroom and is often depicted growing in open grassy fields with broad red-brown caps, but also in advertisements spruiking bedroom cultivation-style shrooms. And my understanding is that they're much easier to cultivate, especially considering the difficulties around cultivating some of the wood lovers from Victoria. In this webcast, Caine is going to discuss the history, taxonomy, and cultural mystique that this species has developed over time. And as a new chapter begins, we chart how this species has gone from an underground topic to citizen science, to a poster child of new mycological research. We also have Alistair McTaggart, who has been collecting specimens and leading Australian research on this intriguing mushroom, admired by foragers and observers alike. His research has led to a new appreciation of the diversity of Psilocybe cubensis in Australia and the possibilities that this species may hold going forward. And I'm just noticing, because I think one of the things that Alistair also covers, this is my own notes, is where it came from as well. And if it is something... nope, he's saying no, shit. I thought you were like, look, maybe that's a question for later. I'm going to save that for Q&A time. So Simon Beck is also here with us to cover the basics around psilocybe mushrooms, including essential topics around safety, harm reduction, including setting, and making the most of a psilocybin experience. And it's funny because whenever I read these things and I'm like, okay, talking to public audience, generally there's a little asterisk in my head because, because of the state of prohibition generally. But we're in a pretty interesting position now with the state of prohibition plus the state of medicalisation. We have two forces not necessarily opposing. We have plenty of substances that are regulated in a way that doesn't allow them to be just bought off shelves and taken, and that's how most medicines work. But I feel like mushrooms are different. Maybe you feel the same. If you do, drop it in the comments. So we'll go to Alistair in just a sec. If you do have any questions, drop them in the chat. We'll keep track of them and we'll get to them. So Alistair has researched mushrooms for 2 years and grown them for the last 6 months. He's using the knowledge of genetic diversity in magic mushrooms to breed designer shrooms that will hopefully benefit adult use in the future. His blog, I'll get somebody to drop that blog into the chat, and I'm going to say bye, and I'm going to say hey there, Alistair. There we go.
Research mushrooms for
and can you hear us?
For the last 6 months, he's using the knowledge of genetic diversity.
Hello.
Is it over to me?
Yeah, you are good to go.
Okay, well, I've got horrible news for you, Nick, because it says host is disabled screen sharing. So while you stitch that, I'll just let you know what I'm talking about. Ronnie asked me to tell you about a new piece of work that we've just published back in December. And it's published in Current Biology, I think, in December. If you want to check it out, the original we published with the manure tour, terrific read. Not as good as the EGA newsletter, probably. But yeah, I think the Current Biology one is not free, but you can get the manure tour one. And you can really see the way that we originally thought about structuring all these data. Then I was like, well, Ronnie, I might as well talk about what we've just put out about subs, because we've got something under review at the moment, and we've put it out to have like comments from the community, and then also just to put it out there, because sitting on it is so, who wants to sit on something? So yeah, you can check out that too. I can't even remember what it's called because it was on the slide, something about with loving magic mushrooms or something. So hopefully I'm going to click and see if I can share a screen. Oh, raspberries. I don't reckon I can keep treading water here. Actually, you know what? I will keep treading water in an interesting way, because I'll tell you a little bit about what I've been up to for the last 6 months, which wasn't going to be a part of my talk. I've been growing magic mushrooms for a company called Fungus. It's been such a trip. And I've sort of, in the psilocybin industry, I've got a slide later on, if we ever get to it, where all the where I've kind of learned about all the vested interests in the psilocybin kind of landscape. And it's fascinating to see. And I think what I really want to say, if I don't get to this slide because we run out of time, is that the real knowledge comes from the underground community, or whatever this community is. Underground, I guessing, so you guys aren't underground. The knowledge that has advanced everything comes from the people. And yeah, I love it. Watching the scientists struggle is horrible.
And it's fascinating.
How are we going?
And I think I really want to say, if I don't get to this slide, we run out of time. Comes from the people. And yeah, I love it. Watching the science and it's fascinating to see on, and I think I really want to say.
I mean, you're going to edit all this out, right?
Hey, Alistair, can I just check quickly? Do you have any audio going on your computer there or anything like that? Are you hearing an echo or delay?
Yeah, it sucks.
You can hear?
Yeah.
Yeah, okay. Sorry, I'm not... Well, like I said, we're just trying to figure out... I have no idea. Echo started when you switched to him. That echo came back. Underground's like sewers and rats.
Me? I don't have YouTube on. I don't even have a browser open.
Okay. Okay. This was maybe coming through to the mic. Yeah, could be. Mic's not on though, so it shouldn't. Let's see. Let's see if there's one more mic that could be coming from. Don't think so. Don't think so, guys. Better now. Let's see. Yeah. Hey.
Ronnie, you got to enable screen sharing for me so I can share the PowerPoint.
Okay.
Better now.
Okay, give me a second.
Yeah.
We found the foul mic. I was thinking it sounded very distant. It's at a computer on the other side of things.
Can be praised. All right, and can I share a screen yet? Oh, no. Oh, bless. Thank you, Ronnie. Let's share this whole bad Larry. Oh, no. Oh, you're not going to believe it. Oh my gosh, I got to quit and reopen. Sorry.
Sorry, guys.
That's right. This is what happens. This is why we live and learn, and we laugh, and then we make trinkets about it. We sell them at shops for $2 each. We make a little. We don't make a lot. We buy a cow farm with it. That cow farm with Betty, our first cow, and Horace, our bigger cow. We make more cows, and then we have mushrooms, and then we acquire Smurfs. No, I ended up. I didn't know there were like there's like 3 of those movies. Hey, Alistair's back.
And you got to give me screen sharing again. Oh, thank you, Ron. You're one step ahead all the time. All right. Ah, sweet. Okay. Cooking with gas.
Hey.
Sweet. All right. I think I've done enough of a waffle intro. You guys know me well enough. Let's just get into it. We were talking about these 2 old things, these 2 pieces I was just talking about. You can pause it later and find where they are. I just want to say thank you to everyone, all the colleagues, collaborators, co-authors, Tanner and Otto, and you to this thank you list. Bless you guys for sending me these photos. I also want to take a massive opportunity to make an apology. Andy B, who also took this photo, is the very first person to ever send me a spore print. And to be a co-author on these pieces, all you had to do was send me a spore print, and in time for me to include your cultures in the pieces. So not hard to become a co-author, but through a communication breakdown, it's always the same. And it was on my fault. So sorry, Andy B. Hopefully I can make it up to you at some point in time. I'm essentially going to go through the figures of these 2 pieces. One is under review, one is published. And it's kind of the way that I would normally read a scientific article. And I'm just going to take you through as the author. And when you've listened to this, you probably won't have to go and read them unless you really have trouble sleeping. So in the cube piece, we were essentially looking at 2 populations, the ones under cultivation and a naturalized population in Australia. Long story short, the mushrooms that are under cultivation or commercial mushrooms have stemmed from very few founding populations, and then a series over the last 50 years, essentially inbreeding from few founding populations has kind of lost allelic diversity. And what's interesting is that it's been supplemented by new introductions from new provenance. And there's been about 7 provenance introductions. So currently under cultivation, based on the mushrooms that we looked at, there's really about 7 places that have been included for all those commercial cultivars. And yeah, we'll get to that. Then the Australian population, 99.9% introduced here. And because it's not been inbred and subjected to kind of grow better mushrooms. It's just been outcrossing and living the dream in manure as you do. And we've got allelic diversity that's going to be so interesting to include in mushrooms in the future. When you compare cubes to subs, it's chalk and cheese, because looking at subs in their center of origin, and you see what they should look like, what the center of origin looks like, what kind of allelic diversity exists. So Australian populations of subs have really high allelic diversity, particularly at mating genes and the genes that produce psilocybin, the genes that control mating compatibility, and the genes that produce psilocybin. We have many geographically separated populations of subs across Australia, whether they're in valleys or on mountain tops, but they're likely all Psilocybe subaeruginosa. There's evidence of gene flow in the recent past. They're sexually compatible. And if you were trying to break them into lots of different species, you would just be describing populations essentially. And that includes the sublookalikes in the Northern Hemisphere. Things like Psilocybe senescens and azurescens are pretty clearly Psilocybe subaeruginosa. And the last thing that I'll talk about is just the diversity of alleles in the psilocybin gene cluster, the genes that produce psilocybin. We've got in subs this amazing diversity, and it's going to be fascinating for someone to untangle why in the future. And I'll take you through a couple of evolutionary reasons why. So if you were reading the old Cube paper, then you'd come across some figures like this. And luckily, you entheogenesis crowd have heard me explain them ad nauseum. You've got these two splits trees. This is figure 1 on the left here, and a supplementary figure on the right. The big one is based on genes. The one on the left is based on SNPs, which are just a couple of 100,000 single differences across all those 124 genomes. And splits trees, of course, branch length is informative of genetic difference or genetic diversity, and reticulation kind of explains complex evolutionary events. Possibly recombination is one way to look at it. When you see things on long branches, it can be genetic difference, or it can be interesting things like clonality or maybe inbreeding even. So if I was reading this Cube paper, and I guess, I actually probably cheat. Normally someone would start at A, B, C and read it chronologically, but you'll see all these colors in these figures, and the colors come from somewhere. They come from this analysis in this figure C. And this is a structure plot essentially based on k-means clustering. And I've kind of spoken about this before. Each vertical line is an individual, and a horizontal line is a theoretical group that you're adding to see how many groups there are among your data. So if there was k equals 1, it would all be one color. When we get to k equals 2, the Australian population separates from the cultivated population, and that's really clear in the splits trees. You've just got Australia separated from all of the cultivars. And in this two-dimensional plot of a discriminant analysis of principal components, in figure B, Australia is on the left of the y-axis and all the cultivars are on the right. So when we finally get to 6, we kind of have the populations that we lived with, or the groups, and they're not clean. So you can use this two-dimensional plot to kind of visualize how these genomes are related to each other. And you'll see I've even named a couple of things that really, even though in the structure plot, they've been given a color or a group, you can see it's not exactly clear cut. And even in the splits trees, this Malabar group clustered within or among the blue magnolia group, something like Escondido, Mexico, is really close to this group Luminous. And what a great segue into Luminous. Luminous is such a fascinating group of mushrooms, not a true group. Am I good to keep going? Sorry, Nick. Oh, cool. This Luminous group in inverted commas is an eclectic mix of genotypes essentially, and it's sort of where all the new genetic diversity is coming from under cultivation. And one individual that you'll hear me mention a lot is this shit one on this long branch, and you'll see it's really heterozygous, and some of these Luminous are going to be such good sources of genetic diversity when people start breeding a little bit more. So the next figure is something to look at kinship. If you're a sibling, you're a brother or a sister or whatever, you share about 25 percent of your alleles with your siblings. And because I knew which individuals came from the same mushroom, I knew the siblings, and I could kind of set a cutoff for what a sibling would be. And we can see Australia down in what you're looking for is kind of triangles in this big pairwise comparison. And Australia is this big triangle, and all the cultivars are this kind of other big triangle. And there's some evidence of kinship among the cultivars. What breaks them up, you can see chipwine down here, it gets all light. So they're not definitely all related, but there is a lot of evidence of kinship among the cultivars. This could be because they've been crossed from different provenances that weren't kin. But yeah, there is some degree of kinship among the cultivars. Penis envy and this kind of luminous group are a bit different to the blue magnolia, golden teacher, and Malabar groups. Hopefully we'll dig in a little bit more to that as well. This is probably the hardest figure to understand in the piece, just because there's a lot going on. In figure A, we've got an analysis essentially looking at heterozygosity and homozygosity to measure something called the inbreeding coefficient. And oh gosh, this jargon, it sounds so horrible. When you're at 0, you have, you know, the expected heterozygosity. You got a good mix. When you start to approach 1, it means that you're probably inbreeding. You've got a lot more homozygous alleles than you normally would. So something like penis envy, which I know is somewhere up here, is really homozygous, tiny little box and whisker plot. Something like golden teacher is approaching 1, and there's not many individuals. There's no individuals down near 0. So these are kind of the two groups that are super inbred. Luminous, you can see, so when you go negative, you've got an excess of heterozygotes, and that could be an excess of heterozygosity. That could be something like you're crossing from different provenances, so in cultivation, or maybe you've collected something from the wild, so something like chipwine, which I think is this green dot sitting perfectly on 0. Bless that chipwine. This one I've shown you before, B, which is modeling effective population size based on something called linkage disequilibrium. You could think of it as randomness of combinations of alleles across the genome. Is a really, really basic way to describe it. And it's not an easy concept to understand. So what's important here, or what really excited me jaw-droppingly, was seeing the Australian effective population size have this massive drop and then recovery, which would sort of equate to a bottleneck followed by random outbreeding again, or just random mating to increase that effective population size. And all these things under cultivation just have a drop and usually no recovery in their effective population size as an impact of domestication. These last graphs down the bottom are tracing measures of genetic diversity across the chromosomes of Psilocybe cubensis, so 13 chromosomes. The interesting one is probably this measure, which is just nucleotide diversity. And you'll see that penis envy and golden teacher across these 13 chromosomes are really low, whereas populations like Australia and luminous are really high. So we're just getting this message all the way along. Australia has high genetic diversity compared to the cultivars, with the exception of luminous, which is an eclectic mix of individuals potentially collected from different places, even though some of those have been subject to cultivation, which is kind of this lot up here, probably the genotypes that are called luminous. Tajima's D, we're going to come across this later on. It's a way to measure what kind of evolution might be occurring. So the reason that we looked at this was to see if there was any evidence in the cultivated populations of a particular locus in the genome being positively selected under domestication or under cultivation. We were looking at such a broad scale, so really at this chromosome kind of scale with massive window sizes. And to be honest, it's not really that useful. We probably want to be targeting genes that we've identified that could be positively selected for, and then narrow down on that. I had run analyses in the past to look for such genes under positive selection, but never turned up any. But that could just be because my pipeline wasn't the best. I hope you're still with me, covering a lot, and I'm going super quick. This is one of my fave figures, but the reviewer hated it and we had to put it as a supplementary. And what it is a way that I've made to visualize how homozygous or heterozygous genomes are after domestication. And essentially, I'm plotting the two most heterozygous individuals from a population and the least heterozygous individual from a population. And you'll see homozygous, it's the density of homozygous sites is this, the dark, kind of the big blocks of color. And then I've just plotted heterozygous density of heterozygous sites in front of it. And it's really telling with penis envy. This is the most heterozygous genome in penis envy, and this is the second most, and then the least. And so in a mushroom, you'd expect at least two sites to be heterozygous, and those are the genes that control mating compatibility because they have to differ. And they occur in chromosome 1 and chromosome 10. And then in penis envy, you get that, and you get a couple of other little spikes, but really it's just this incredibly homozygous genome. Our other really homozygous group is this golden teacher group, and you can see that the pattern is almost consistent across all of golden teachers. So the heterozygosity, the places of heterozygosity are really similar across it all. And then look, here's chip 1. So this is probably something that's been recently collected from the wild. Oh, sorry. And you can just see that's how a mushroom in the wild would probably normally look. The last little part of cubes before to see the same analyses, this is a way that we visualized the diversity of the genes that control mating compatibility. And this is where we kind of can, Tim, James, and I were starting to talk about provenance and how many sites across the world have fed or populated the cultivated mushrooms. So really, in a normal population of mushrooms, and we'll see in Psilocybe subaeruginosa, it's usually the mating genes are really highly diverse. When you're tetrapolar, often over time, you end up wanting to differ at these alleles. So because when you differ, you can cross with more things, more other individuals, more other genotypes. In this population, the cultivated population, we've got 3 dominant alleles of mating genes, A, B, and C. And so those are really present in our dominant cultivars. Then we've got a smattering of other little introductions of mating allele diversity. So something like Malabar, and then our little Thailand provenance ones. And then we've got all these green dots of our little luminous groups and penis envy. There's actually 14 alleles at these mating compatibility loci in Psilocybe cubensis under cultivation. And because they're heterozygous, if you divide it by 2, you get 7. So there's a minimum probably of 7 sites or 7 populations that have founded Psilocybe cubensis under cultivation and that have been included in our analysis. If that makes sense, then great. It's also possible that over time, there has been a loss of mating allele diversity in under cultivation. But if you look up negative frequency dependent selection, it's a little bit tricky because it's a contrived population and domestication is obviously having an impact in there. So 7 or more have kind of founded this diversity. And from what we've seen, golden teacher, which is kind of cultivated the longest, is probably from 1 or 2 populations, which is why we have 3 MAT alleles in it. And that's why we have low genetic diversity in it. So it's founded from very few individuals. Okay, subs. And this should all look familiar because just really repeating what we did with the cube work. So we've got genes and SNPs on this side. So let's start with where we started with cubes in this kind of structure plot, looking at how we've defined the populations. And we see at K equals 2, so a minimum of 2 populations, we kind of get this southern Tasmanian, South Australian Western Victorian is different to everything to the east of the range, sort of. And that holds true in the 2D plot, in the structure plot, and in our splits tree analyses. And we max out at 6 populations, which is pretty much equal to the sites that were sampled, sort of, in a way. So the way that I now think of subs, and the way that I have maybe tried to explain before to get you on the same page as me, is that each of these clusters in these splits trees is essentially a dikaryotic parent. So really, even though we've got about 90 genomes in this study, I only have 1, 2, 3, 4, I think about 20 clusters. So 20 dikaryotic parents. So the sampling isn't that great. Eventually, if we sampled from every single dikaryotic mycelium around Australia, we would expand out this splits tree network into probably a nice wagon wheel. And to help kind of clarify this, so this Ravensbourne collection is from 1 mushroom. This Bunya collection is from 3 different mushrooms printed from 3 pili, and you can see A, B, and C, but they all cluster together. Caine and Bill sampled many different mushrooms. Caine kept his prints separate, so E is all from the same print there, but they get this kind of sibling arrangement, so they have a very close relationship. And this is such a great example of a council or a landscaping company spreading mulch around that's been infiltrated by Psilocybe cubensis and spread long distances. On the other hand, in Tasmania, Jan, who collected in Ellendale, has collected at least 3 pili, MNO, and so 2 of those pili came from the same dikaryotic mycelium, and O came from something else. And the same with Caine. At Kununyi, he's got R, P, and Q. So at least 3 different mushrooms, but sampled from 2 different dikaryotic mycelia. So hopefully you're with me on that. And over time, if we collected enough of them, we'd eventually probably, if we don't already, we'd find the parental dikaryon of Psilocybe senescens or Psilocybe azurescens. And that's the dream. Okay, I think that's all I need to talk about there. So kinship, again, we do have some evidence of kinship across these populations. So there's Bunya, even though we could see that I collected from 3 different mushrooms, they're all kins. And Caine and Bill, this is probably I've got a little bit of a harsh setting on whether I truly called it a sibling or not. We're looking for the big triangles. So there's the Bunya, and you'll just see the triangles kind of map across the populations themselves. And then there's a kind of a big triangle here with Victoria kind of mixing with Northern Victoria and New South Wales, and sort of the same here. So there's some degree of kinship among Psilocybe subaeruginosa populations in Australia. Now, while we're on this, we might as well talk about biodiversity and species diversity in subs. So, because lots of names have been applied in subs, and some of them based on morphology, some based on ITS sequences, which is sort of that marker is sort of a proxy for species biodiversity in mushrooms, in fungi, a lot of the time. All this figure is doing is taking an ITS type, so a genotype of ITS, and then it's on this tree here, so you can see the relationships. And then this is called a haplotype network. And each of these big circles is one of those ITS genotypes from the phylogram, but with the kind of all the sampling from GenBank. So in this circle here, we've got 34 individuals that have a sequence from this part here, or this one with cyanescens and Alenii has 24 individuals, mostly from GenBank, and a couple from Australia. I believe those were the Bunya ones. The lines separating these genotypes, the number of hashes is a parsimony informative character. So these ITS sequences don't really differ by that much. Think back to those networks, which are based on literally millions of SNPs. And this is essentially 500 or so, a gene region of about 500 base pairs. And we're talking about a couple of individual differences. What is interesting is, of course, the New Zealand samples, so Makarore and Werraroa. currently in an ITS tree, Psilocybe subaruginosa is paraphyletic with regard to those 2 taxa from New Zealand. And what we would want to see eventually is people sampling the New Zealand populations and putting them with the subdata to see if they're true species or if they are clustering as a population of Psilocybe subaruginosa. And what I was saying earlier is if we started to try and break up subs into different species, we're essentially just describing populations. Cubes also have some polymorphisms in the ITS region. For example, these are pretty much all the cultivars, and here's an Australian genotype of ITS, another Australian genotype of ITS. So there's polymorphisms in cubes as well. And I just wanted to show a slide of the phenotypic variation, just because I think sometimes we see all this diversity, this morphological diversity in mushrooms, and it's almost a shame that there isn't more than one species. We've got beautiful wavy caps, you know, sinuate kind of pili. We've got conical or convex pili. We've got rich chocolate browns. We've got caramels. What a shame that there's not, you know, 5 or 10 or 30, who knows, however many species you want with populations. But yeah, this is all the genetic differences point to it all being one species. And cubes, since I've been working on them, you know, you do have morphological variation as well. You've got big annuli, you've got this kind of treasure coast morphology. I don't know how you would describe it. You've got flat caps, you've got round caps, and there's phenotypic diversity in cubes. Yet we don't get so worked up about whether they're different morphologically. We just call them a cube. So yeah, each to their own. Quite frankly, if you want to call something Psilocybe cyanescens and you live in the United States, then that's great. You're communicating. Taxonomy is about communication. People understand what you're talking about. Today I read a paper, they've just changed Corymbia, which is a eucalypt in Australia. They've just changed its name to something new. But people still know what you're talking about if you're calling something Corymbia, and communication is really the name of this game here. Okay, this is allelic diversity of mating genes in the natural population. So we know we've got about 20 individuals that we looked at in subs, even though there's actually about 90 genomes involved. And we probably have 40 or so alleles here. In that whole cube population, we really had 3 dominant alleles at the same genes. And it just kind of shows, well, this is what a natural population looks like. High allelic diversity at these mating genes. And of course, I did all my crosses based on differences in the mating genes. And I was so interested, of course, to see the populations from the Bunya Mountains forming a compatible dikaryotic mycelium with things from Tasmania. So showing that these disparate populations are still sexually compatible. Okay, this is the best part. Somebody better shut me up, because the time has gone all haywire with our stuff up at the start, because I could talk about this all night. This is a haplotype network of Psilocybe cubensis, the genes controlling the production of psilocybin. So these 4 or so, or I can't remember how many genes I've included. It's based on amino acid differences. And what we see here is that 60 of the kind of 84 or 80-ish cultivars all have the exact same alleles that produce psilocybin. We come over to Australia and we've got 5 genotypes producing 5 different ways that these genes differ in their production of psilocybin. Then we've got our lovely eclectic luminous, this green group, and penis envy producing different psilocybin, just with different genetic background, whether that translates to different transcription, different translation, more effective, whatever. It might mean that maybe you've got more baeocystin than psilocybin in one mushroom to another. So what I've been doing, I wasn't even going to talk about this now, but I might as well, is taking these 5 Australian alleles and crossing them against everything that I know is homozygous in the cultivars and seeing what happens. And hopefully I'll be able to share some data on that soon. Because of the worldwide shortage in standards for all these tryptamines, I still don't have the data yet, which is such a bummer, because we've grown like many of these genotypes based on these differences at the psilocybin loci. With subs, if I tried to present this like a haplotype network, like with the cubes, it would look hectic. And that's just because nearly every single population, every individual has a different alleles behind production of psilocybin. Essentially, if you are collecting Psilocybe subaeruginosa and you're collecting geographically and you're collecting in natural populations, you are probably collecting different genotypes of that psilocybin pathway, which is super interesting. If you're collecting out of mulched garden beds, then you have less chance of doing that because single genotypes can be spread more easily. Subs are at the point where they have so much allelic diversity in that psilocybin pathway and evidence of recombination in the pathway itself. It's just hectic, and I don't know. We haven't really explained it that well. So we were looking at Tajima's D, so this kind of explanation of what's going on in terms of evolution. And when we have negative values, we might have something like fixation or positive selection. And when we have positive values of Tajima's D, then we might have something akin to balancing selection. So there might be a benefit to maintaining a lot of allelic diversity in a population. But why? And I think that is going to be such a cool question to tease out, because subs are going to be a model for why psilocybin is in the environment. Yeah, and I think I can't wait for someone to start asking this question. And it's not a good segue into the next slide. So this is ages back when I was talking about the psilocybin pathway and woodlovers paralysis. And I have to apologize, Nick and Simon, I haven't read that newsletter yet and about the current woodlovers hypotheses. So ages ago, I think we were telling you about the gene duplication of Psi-H. So psilocybin is a metabolic product of tryptophan through a pathway of about 4 genes, and it goes through a series of tryptamines, and Psi-H does something, I can't remember what it is, 4-hydroxytryptamine into norbaeocystin or something. I can't remember, tryptamine into 4-hydroxytryptamine. And we were hypothesizing that if you've got functional copies of an additional Psi-H gene floating around, maybe it's making new analogs that could potentially bind to peripheral serotonin receptors to cause a temporary paralysis or something along those lines. And essentially through something that Jason Slott did, this is a clinker plot, and he's looking at synteny, which is just kind of gene order, I guess, of the psilocybin pathway across the diversity of Psilocybe subaeruginosa. And really what it all kind of boils down to is subs always have one functional copy of a Psi-H gene, and then a handful have a functional copy of another Psi-H gene, but a lot don't have a functional copy there. And then pretty much always the third copy is a pseudo gene, so it's non-functional. And then occasionally, in some individuals, you get the position of these two Psi-H's swapped around, which is fascinating. So there's a lot going on at Psi-H in the psilocybin pathway in Psilocybe subaeruginosa, and it's certainly going to be interesting when people start exploring these genotypes a little bit more, maybe in line with woodlovers paralysis, but I don't know what the current hypotheses are and if that's been rejected yet. Okay, do I still have time? Someone give me a nod.
It's not a
nod. No one's giving me a nod. I'm going to keep going, because I want to talk about, so what you might have noticed is that there's no more UQ branding on my slides. I finished at UQ on the 1st of December pretty much. And now I feel a little bit freer to talk about why I got into working on magic mushrooms to begin with. And I was fascinated from magic mushrooms from day one after I tried them. And it's part of the reason why I've always been working in mycology. And it's taken me this long. I've formed opinions about very few things because I'm not very smart, and I don't think I deserve to form an opinion about stuff. But finally, I think I can eloquate where my opinion is with designer shrooms. So let me take you on a journey through time and space, essentially based on a clock-like rate of evolution. Psilocybe is between 20 to 100 million years old. And we think that psilocybin is probably in the most recent common ancestor of psilocybe and is a similar age. And although we don't really know the reason it is produced, we can still speculate that it is targeting serotonin receptors in metazoans. So things like any animal really, slugs, nematodes, insects, whatever. And is it a repellent and attract it? Whenever I am having a psilocybin experience, because I think about this a lot during it, I think, man, maybe they're playing 3D chess. And as a segue, someone was sending me an email about how they watch slugs' behavior change to diurnal from nocturnal when they're fed Psilocybe subaruginosa. Apologies to the person who sent me this if it was confidential. Oh my, this is embarrassment. But yeah, maybe mushrooms are playing 3D chess by making their slugs get eaten during the day when they're active instead. Who knows? I don't know. I wish I did. Anyway, in that period of a couple of million years, 20 or more, we've had diversification of psilocybe in niches all over the world, usually in similar niches: wood, leaf litter, dung, moss. And you can imagine that maybe in Australia, you're predated by slugs. Maybe in Central America, you're predated by nematodes primarily. And time and again in evolution of secondary metabolites, when they're interacting with an animal or something else, then we have kind of a honing by evolution to best fit whatever is eating you, or else in that coevolutionary arms race, you might as well not be even producing the compound. So is it reasonable to suspect that something that you collect like Psilocybe subaruginosa that's predated by one thing might give you a different experience to something that's predated by another? If you're on the same page with me there, then let's take it up a notch. Imagine this: in one species with all this allelic diversity in the way that you produce psilocybin. And can that give you differences in experiences? And I just put forward, if wood lovers paralysis is an impact by the psilocybin pathway, then potentially that's a really clear-cut difference in, well, yeah, you do get a different experience from different genotypes of Psilocybe subaruginosa. But I mean, that is an extreme example and still a hypothesis at that point in time. So if you're still with me, you're in a position to kind of understand where I'm coming at with starting to explore these different alleles and whether we can change the psilocybin experience. When I first started this, I could never have voiced this opinion because set and setting and strength of dose were the two loud reasons of how you experience psilocybin. You change the set and setting, you might change your experience, or maybe you've changed your dose if you've had a different experience. And yeah, it's so interesting. I wish that we had a way to collect these data in the community. Simon and Caine, with their work on wood lovers, have had success in getting meaningful data from the community. I really am so interested in this area. I hope that there's a way through EGA to start collecting meaningful data. Remember, if you're collecting subs from two different parts in natural environments, then you're probably experiencing different phenotypes of psilocybin. Sorry, different genotypes of psilocybin. Does that impact your phenotype in the terms of the experience? And yeah, the dream is that it's not just slugs that get to experience these different genotypes and know what's going on. All right, I'm going to skip those outcomes again. I put this slide together just because and I was kind of talking about it before my talk started, when we were still messing around with sound and whatnot. And I don't think I'll go through it now because I feel like I'm harping on too long. Really, my point is that I was saying before, and the reason where I've landed on this is, yes, 40% of people will experience a mental health disorder in their lifetimes, and psilocybin may benefit them. Of course, it's really hard to get a negative control for psilocybin, and watching psychiatrists talk about it drives me wild. I am now more interested in 60% of the population who may not experience a mental health disorder, but that may still benefit from psilocybin. And I don't think that you should be penalized for wanting to have that experience if you've educated yourself in the risks of psilocybin. I've put up some of the vested interests. I'm obviously a vested interest in here. So yeah, take that with your medicine. So this could be my last talk for EGA. Who knows? It depends if I've got new data based on the genotypes. And I'd just like to say it's the first time in my mycological career that people have been interested, and it's just been so flattering and just really, really fun. You've just made it so much better to make me think that my work had some value beyond the scientific community. So thanks, Emily, and hopefully we'll encounter each other at some point in time. Bye for meow.
Thank you. And I think I'm successfully reflecting the general gist of the comments, comment section there, in that people are very appreciative of this, and hope that this isn't the last time that we see you.
Over to you, Nick.
And we would love to hear more stories, more of what you learn along the way. Thank you very much for that. As I said, keep those questions in there. We will do a Q&A soon. But right now, I'm going to hand over to Simon Beck. This is EGA's Garden States Webcast.
Hi, my name's Simon. I want to start by thanking EGA for putting on another awesome mushroom-related event. Really appreciate every event you guys run. Always a pleasure to be involved. Also start off by saying that this is a harm reduction presentation. I'm not condoning or encouraging any illegal activity, but it's important that if people are going to decide to ingest psychedelic mushrooms, they need to know how to do that in a safe way and minimise the harms that are possible. And I think it's important that we recognise that there are possible harms associated with the ingestion of psychedelic substances, and particularly with psychedelic mushrooms, given the risks around misidentification and the possible ingestion of toxic species, among some other factors like variability in potency between specimens and species, which we'll dive into a little bit here. This is going to be a really brief rundown of some basic harm reduction principles. I have given another talk about set and setting and optimizing the psychedelic experience to reduce the risks of a bad experience for EGA before, and you can find that on their YouTube channel. It's the summer mushroom season in the northern part of Australia at the moment, which means that there are Psilocybe cubensis and Panaeolus cyanescens, as well as some other less common species growing in dung in the warmer parts of the country. And they pop up after rain, and I think we've had lots of rain up on the northern parts of the east coast at the moment, so there are plenty around. When I think about approaching a psychedelic experience, I like to use a who, what, where, when, and how framework. So I'll run through that really quickly. Some of them I'll focus on a bit more than others. And again, I've talked about this in some more detail in another video. The who component is essentially thinking about who you should be taking these substances around and with. And, you know, there's some obvious factors in that in terms of interpersonal conflicts and relationship issues that you might be having. But I want to talk specifically as well about the importance and recommendation to have a sober sitter with you, ideally in person, although some people do find it helpful even if they can just tee up a friend that they might be able to contact remotely or have touch base with them during the experience to make sure things are going okay. I think particularly when you're starting out and getting familiar with these substances, it's really important to have someone sober with you, ideally with you in person, and hopefully someone who's got a bit of experience with these substances themselves that can help, you know, ground you a little bit if things start to go a little bit hairy. The other thing that I really wanted to touch base on here is the issue of consent. It is really difficult to consider and obtain consent for intimate contact while under the influence of these things. I think it's something that everyone needs to think about very closely and in a very considered way. And if some intimate contact is potentially going to be on the cards, it's really important to have a conversation about consent and how that's going to be approached during the experience beforehand, and again revisit it during, remembering that consent needs to be obtained at the time of the act and that it can be revoked at any point during the act. You should never feel pressured to allow intimate contact that you're uncomfortable with, and also you should never take these substances around someone that you get a bad vibe from or think might take advantage of you or in a position where you might be vulnerable, because unfortunately that sort of abuse does occur, and when it does, it's obviously extremely traumatizing and it's never acceptable in any way at all. So please do keep those conversations front of mind and consider those things as well. The next important thing is what. So that is, what are you taking? it's really important, the species of mushroom that you are going to ingest, because the dosage does vary widely, species to species. It's also important in terms of Psilocybe cubensis, where it's been cultivated, to know something about which strain you're taking, because the lineage of strains that comes from the penis envy variety can be up to nearly double the strength of some of the other more common varieties of Psilocybe cubensis, which means that you might need, as little as half the dose as what you would normally be taking to get the same level of experience. So if you're using or purchasing or being given cultivated mushrooms, ask what the strain is as well, and do a bit of research on it before you dose that. The two common species that I mentioned before that do grow in this time of year in the warmer climates are Psilocybe cubensis and Panaeolus cyanescens. They come from two different genera. Generally speaking, Panaeolus cyanescens probably about double the potency of Psilocybe cubensis, and even more, relatively speaking, if you're consuming them fresh. Pancyans tend to lose a little bit more potency than cubes when they dry because of the mix of the alkaloids that's in them. But, as a rule, you should be looking at least half the dose or so to start with, until you're familiar with that batch of that, of that specimen. So the other thing there is then the difference in potency, one mushroom to the next. The two mushrooms growing next to each other in the field can still be quite different in potency, even if they are the same species. So the general harm reduction advice that's given is to prepare multiple doses at one time, either by drying multiple doses, powdering them and homogenizing the powder, and then starting at a low dose with that new batch of powder until you're familiar with the potency of that batch, or putting together a aqueous extract, a tea or a lemon tech with multiple doses, and then storing it safely, usually by freezing it in individual doses. And getting familiar with the potency of that tea. Again, always starting low and going slow. There's nothing heroic about overshooting the dose that you were going for, or starting at a really, really high dose, particularly when you're starting out and you're unfamiliar with these substances. That's a pretty risky way to approach it in terms of having a bad experience and maybe going a bit deeper than you intended to, which can be pretty overwhelming, especially when you're not familiar with it, or perhaps you're not in the right setting for that particular dose range. The other thing is food poisoning issues and contamination issues. Fungi are like any other food. They can and will go off if they're stored incorrectly, or if you've picked them when they're past their use-by date. So if they smell funny, if they look mouldy, if you've made a batch of tea and it's been sitting in the fridge for more than a couple of days, don't consume them. You certainly don't want to be dealing with food poisoning while you're in the midst of a psychedelic experience. That would be awful. So bear in mind those sorts of food safety approaches as well. Generally speaking, when people make an aqueous extract, they add some ascorbic acid to the mix, be that from citrus juice or from vitamin C tablets, to prevent oxidation. When the tea is turning blue or the mushrooms are turning blue, it means that the product is oxidizing and the potency is being reduced, and some ascorbate can prevent that from happening. The next thing is where. Where are you going to take these things? It's important that you're comfortable. It's important that you're feeling safe. It's important that you've considered what responsibilities and distractions might pop up. If you have to go to work really early the next day, it's probably not the right time to dose mushrooms late at night. If you are the only person looking after your kids that night, it's probably pretty irresponsible to take psychedelic mushrooms and still have that responsibility there. Likewise, think about pets and just any other responsibility and distraction that might pop up, and factor those in, and certainly plan around those in advance. You don't want surprises happening during the middle of the experience that mean that you suddenly have to deal with some sort of responsibility. Likewise, thinking about dosing these in the bush. If you are going to take these in the bush, you need to have someone sober with you who can drive for help if need be. Ideally, you'd be going somewhere where there is mobile phone reception, which is often a challenge in rural Australia, but it's good to have a bit of a backup emergency plan, and sometimes just having thought about that in advance makes it less likely that you're going to start freaking out about what might happen if something goes wrong once you're in the experience, somewhere remote or out in the bush. Thinking about when you might want to take on a psychedelic experience. A lot of people use these to deal with some sort of trauma or do some inner work, or, you know, get a different perspective on life, or maybe evaluate where they're at and, you know, where they want to go. With that said, if you're going to be approaching it with that sort of therapeutic intent, I think, you know, more preparation is really important. And I think more consideration then needs to be given to the appropriate setting where that sort of work can be done. It may not be the sort of work that you want to do in a social setting at a party or something like that. And a lot of people just take them to have fun. And depending on your intention there, the dose that you're going to take, where you're going to take them, who you're going to take them around, can all be a little bit different. So it's important to think about your intention and then factor that into the rest of these considerations as well. When you are looking to do some sort of internal therapeutic work, I think there is a slightly greater chance that things can get a little bit dark. And again, really important then to have someone experienced with you that you trust, who can help, you know, work through any difficulties that might emerge, not necessarily by trying to do some therapy with you at the time, but just by trying to be able to ground you, distract you, bring you back into a happier place. Also then thinking about, you know, making sure that you've got some food and some snacks and things like that around with you at the time, which probably fits better in where. With the how, some people do just eat the fresh mushrooms. Again, because of the difference in potency one specimen to another, I don't think that's the best approach from a safety perspective. And also the cellular structure of mushrooms made of chitin, which can be pretty hard for some people to digest and can increase the gastric upset that you might already experience just from the active chemicals themselves. So most people, I think, these days are preferencing to move towards making an aqueous extract, be that a tea or a lemon tech. When you have made an aqueous extract, the actives are going to be absorbed more rapidly because your body's not trying to get them out of the mushroom material itself first. And when it's absorbed more rapidly, it is going to reach a higher peak concentration for the same dose than it would if you were eating the mushrooms. And it is probably going to be a slightly shorter duration experience. So if you're making a tea, you might need a slightly lower dose than if you were planning to eat the mushrooms and eat the mushroom material, where your body would then have to pull the actives out a little bit. And it might be a slightly higher peak experience and a slightly shorter experience as well. Another really important harm and safety aspect is the legality. The TGA have rescheduled psilocybin to be used in supervised medical settings for treatment-resistant depression. That changed nothing in terms of personal possession at all. Still very much illegal. And I think a lot of people would be surprised to hear just how severe the penalties can be and the weight limits that are applied in a lot of the states. In many states in Australia, the weight limits for mushroom charges are actually based on weight limits that were intended to be applied to pure psilocybin, bearing in mind that dried mushrooms tend to be, you know, maybe 1 to 2.5% psilocybin, depending on the species. You can imagine that the weight limits for pure psilocybin versus mushrooms are going to be vastly different. So as an example, in New South Wales, a commercial quantity is 25 grams. They don't care whether it's fresh or dry. And that has a potential maximum sentence of 20 years in prison. And usually for a commercial quantity, bail will be refused, which means you would often then find yourself in remand for the duration of the wait until the trial is heard. 100 grams is a large commercial quantity, which carries a maximum potential penalty of life imprisonment. Some states have different laws. The weight limits vary. The way that they consider mushrooms versus psilocybin can vary in some states. So check your local legislation, make sure they're familiar with it, and bear in mind that these mushrooms are still very much illegal, and the penalties can be really severe. For the Australian Psychedelic Society, we presented someone's story where they had been remanded to a maximum security prison for quite a few months, facing a commercial or a trafficable charge for, I think, about an ounce of mushrooms. So just bear that in mind. Penalties can be severe. And the other thing with these mushroom species that tend to be growing on farmland, where there are cattle and ruminants around, is that trespassing can actually carry some pretty serious penalties in and of itself, and attracts a lot of negative attention to the whole scene. So always get consent to enter someone's property first. Never trespass for the sake of getting some mushrooms. And the other reason why not to do that is from a biosecurity perspective. It's the same as if you were picking the cold weather species woodlovers in the forests, that you can track diseases and pathogens and seeds of weedy plants from one site to another if you're not adhering to biosecurity principles. So when you're going between sites to pick, you need to make sure that you sanitize your boots, remove any potential seeds, remove any potential spores and bacteria that might cause, foot rot or other transmissible livestock diseases and transmissible weedy species. So if you are going to be getting permission and entering someone's property, please make sure that you've also adhered to those biosecurity principles as well. I know that's a lot of really serious stuff, and I think it's still really important to think about these things in advance. If you have a good plan, if you've thought things through clearly, it is much less likely that you're going to have a difficult experience, and it's much less likely that something seriously bad can happen during the experience because you've approached it in a prepared and deliberate way. And I think for a lot of people, just knowing that you've thought about it clearly lessens the chance that the experience gets tainted by a lot of anxiety that might come up if all of a sudden, while you're entering the psychedelic space, you start to freak out about, hey, what are we going to do if someone trips over and breaks an ankle out here? Or, what are we going to do if, one of us gets into a really difficult psychedelic experience out here in this isolated place? Or what am I going to do now that I've started freaking out and I'm alone and no one knows that, that I'm doing this today? Who do I call? So having all of those things figured out in advance, I think, actually reduces the chance that things go bad in the first place, and certainly means that everyone's more likely to be safe and enjoy their experience and get the most out of it. So, yeah, thanks again, EGA. Really brief harm reduction rundown, and please check out the videos on the Australian Psychedelic Society YouTube.
Well, that was far more abrupt than I thought. Sorry, Simon, I hope I didn't cut too much at the end of it. I was just trying to, not break the end there. Brilliant, thank you, Darklight says. Brilliant rundown, Simon. Thank you very much. Thank you very much to Simon. And we do have Simon waiting in the background for our Q&A session. So if you do have those questions, drop them into the chat. Our moderators are there and are hopefully answering some of them and taking down others for later. And you're seeing right now Caine. Hi, Caine.
Hi, Nick.
I thought I'd say hello there. I believe you're going to talk to us about, I don't know where the framing is. We'll have to learn these things. It's weird with cameras. I know how to talk to a webcam, but it feels a little isolated. About Cubensis?
I am tonight talking about Psilocybe cubensis.
Yes. Yeah. Excellent. All right. Well, do you need anything?
No.
Do you want to? You've got some water?
I'm all
mushrooms.
Good. Let's do this.
Let's do that.
Let's talk about Psilocybe cubensis. Hello, everyone. Good evening. So the topic of tonight's webcast is Psilocybe cubensis, and opening with this beautiful shot of a group of cows and Psilocybe cubensis. So I'm going to be talking about identification, history, and diversity of said mushroom. So Psilocybe cubensis. So let's introduce some terminology here. So Psilocybe cubensis, this is the binomial for this species. So Psilocybe is the genus and cubensis is the species. Psilocybe is broken down into psilos, meaning bear, and cybe, meaning head. So it's bare-headed. Its species name comes from Cubensis. It comes from its location, which was Cuba, which is where it was first collected. So Psilocybe cubensis is a dung-loving fungus, and it's referred to colloquially as magic mushrooms. Cubes, cubies, gold tops, golden teachers, or just plain old goldies. Within the literature, it does have some synonyms. So Stropharia cubensis, which you will hear Terence McKenna use repeatedly in many of his recordings. But it was also known as Nematoloma caerulescens, Hyphiloma caerulescens, Stropharia caerulescens, Stropharia cyanescens. This image here on the right-hand side is a photograph of the holotype of Stropharia cubensis, collected by Earl, and it was deposited in the New York Botanic Garden Fungarium. Psilocybe cubensis is one of the better known of the magic mushrooms. Other species that are also well known within this group are Psilocybe similanciata, the well-known liberty cat from the United Kingdom and Europe, which also occurs in cold parts of the United States and within the colder parts of Australia and New Zealand. The Psilocybe suberugonosa group, which is probably referred to as section Suberugonosae nowadays, and it includes Suberugonosa, cyanescens, and Alenii and azurescens. And then, of course, here on the left-hand side is Psilocybe cubensis, which is probably really the better known of all of the magic mushroom groups, given its countercultural use. It is the most recognised magic mushroom, but it is mostly regarded as an introduced species in most parts of the world. We're still a little bit uncertain about where it's endemic to and where it was originated from, but it has been spread quite widely through tropical and subtropical parts of the world. It is well known also because it's easily cultivated. So the books by the McKenna brothers, Stephen Pollock, even Paul Stamets and numerous others describe various ways of cultivating it. It's incredibly easy to grow, and it is possibly one of the most cultivated mushrooms on the planet. If not so much kind of on an industrial level, certainly by a peer-to-peer level. You know, small little containers of mushrooms growing under people's beds or wardrobes around the planet. There's also numerous strains. There's a whole culture around this itself. Growing golden teachers or PNDs and new strains that are coming out like Tidal Wave and its throw-off mutant variant Enigma. It's one of the classic psychedelics. The active compounds include psilocybin, which is the prodrug for psilocin, and there's numerous other tryptamines present. Psilocin is found in a range of 0.14% to 0.42% dry weight, and psilocybin 0.37% to 1.3% dry weight, as per Tsujikawa in 2003. The Oakland Hyphae psilocybin cup, though, has really changed things in terms of our understanding of how much Cubensis can produce some of these compounds. So let's dive into the taxonomic description. So its habitat, it's an introduced species, and it's associated primarily with cattle. It's a secondary decomposer. So it breaks down already broken down plant material, essentially dung. It grows in open grassland, and it's often found growing from cow pies or from really heavily manured soil. It requires rain and warm, humid conditions in order to be able to grow. It's found in Queensland, and it's also found in New South Wales, within Australia this is, as far south as Kiama. It is likely to grow in Northern Territory and Northern Western Australia, but we currently have no records. It would be fantastic for someone within the community to submit some records and some photos. Its season is from October to March, invariably, but some people do report a much larger season than this. In tropical parts of the world, Psilocybe cubensis will grow all year round. The cap is conic to convex. It has an umbo.
Friend. 1 second, your AV team is here. Your AV team. Let's try that. Cool. Keep going, my good friend.
Okay. Did we drop out at all?
No.
Okay, just repositioning. Okay then. Where was I? Cap. The cap is conic to convex. It has an umbo. It's red-brown when young, then changing to golden yellow with age. It has a universal veil, and remnants can be seen on the cap. You'll be able to see this in some of the photos as I go through. The gill attachment is adnate to adnext. The gills are close, they're narrow to slightly wider at centre, pallid to grey, dark purple to black in age. The stem is white to yellowish with age, and there is the presence of a persistent annulus. It's also worth mentioning that the cap, which is a standard feature of most Psilocybe, the cap is hygrophanous. So as the cap dries out, hence the colour change in time. And this has caused some confusion with a few mycologists in the past. Here's another look at these gills. So you can see that they're quite close. They're narrow and slightly wider at the centre. They're pallid to grey, dark purple to black in age. They can be mottled and the edges tend to remain whitish. And there's that adnate to adnext attachment. You may be able to see that in this photo, and if not in this photo, within one of the following photos. Here's another illustration of the gills. So lighter in colour, and then as they age, they become mottled and darker in colour. Here on the left, here's that attachment. It's only just kind of touching the stem. It's only just attached a little bit. On the right-hand side is an example of the separable pellicle. So you can peel, when the cap is quite young, you can, if you're careful, you can peel away this gelatinous layer. Again, another typical feature of the Psilocybe group. Here's an example of the changing cap colour over time. So on the left hand, you can see that really dark red, tawny colour. And then as it ages, so going from left to right, you can see the colour and the change in colour. So this one kind of in the middle to the right, you can see that golden colour coming through, still with a little slight tawny colour on the umbo, but then on the far hand right example, you've got that purple kind of whitish colour kind of coming through there, and more golden in the middle of the cap on the umbo. Here's the partial veil that then will fall away, revealing the gills, becoming the annulus. And another example here on the right-hand side of the change of colour on the cap, but also how the cap opens. In really old specimens, the cap can even become upturned and kind of be a little bit cup-like. An example of a specimen found in open grassland on dung, and another example of open grassland on dung. This specimen is really quite pale, it's quite bleached by the sun. Okay, so the origins and distribution. This is the current distribution as per iNaturalist. So this was a screenshot taken from about 2 days ago of the current distribution of Psilocybe cubensis. You can see in Australia, that it comes down to approximately mid-coast New South Wales, so or a bit less, a bit lower than mid-coast actually. But as per, to counter a little bit of mythology, Cubensis does not occur in Tasmania. There is a strain out there called Tasmania, named after a specimen having been found in Tasmania apparently, but no, it does not. It's also not found in New Zealand. The main distribution seems to be in the around Mexico, around Florida, and down through Central America into South America. Also have a few in Thailand that kind of pop up as well, and hence these Thai strains and other Southeast Asian strains that seem quite popular. But where does it originate? So Psilocybe cubensis grows mostly on cattle dung, which are boss species. So there seems to be quite a bit of symbiosis here. So the symbiosis with cattle, but also the cattle egrets, the birds that kind of feed off mites and things that grow on cattle. It's been said that the egrets may actually help distribute some of the spores. Psilocybe cubensis is also known to grow on buffalo and elephant dung. Going through the literature, it turns up the bovini tribe, which is where boss and buffalo, etc., come from, evolved around about 11.7 million years ago, which is about concurrent with the evolution of Psilocybe cubensis. So perhaps that's kind of where this relationship between cubensis and the boss group began. Can we refer to cultural associations? Were there any other cultures who used it? It does turn up in some places, but I'm not going to touch that in this particular talk. Maybe I'll come back to that another time. This is a brand new phenotypic diagram, and we can see here you've got, I'm not sure if you can see my mouse, but you've got cubensis here. It's part of this clade that's then connected to Avoideo cystidiata, Psilocybe hopeyi, and then also closely associated with the wood-loving group section Spruiking. Down here at the bottom left-hand part of the diagram is the age of where we expect these species to start to diverge. And cubensis seems to diverge around about somewhere between 10 to 20 million years ago. This is the distribution of cattle. So we've got two primary domestication centres, so the Indocene cattle and the Taurine cattle. So it would depend on the climate at the time as well. But we would imagine that, you know, with the spread of the Indocene cattle from India, and that there are some interesting myths about use of cubensis in Hindu belief systems within India. But we would imagine that perhaps this is one of the major centres, and from India, cubensis would then spread westward, then into Africa, and towards Turkey, etc. And then also down into Southeast Asia. And this is an illustration showing Bos indicus migration waves. And YBP stands for used before present. So you can see that some of these migrations are potentially fairly recent, particularly there with cattle having been taken to other countries, so South America and North America, so less than 150 years before present, and then to Australia less than 90 years before present. But that's possibly disputable. Let's dive into the history a little bit. So there were a number of independent descriptions of Psilocybe cubensis. It was first named and described by Franklin Sumner Earl in 1906 as Stropharia cubensis from specimens found in Cuba. In 1907, it was described as Nematolona caerulescens by French pharmacist and mycologist Patelard. Nematolona caerulescens was then renamed Hyphiloma caerulescens in 1912 by Ciccardo and Trotter, and then again renamed as Stropharia caerulescens by Rolf Singer in 1936. In 1941, it was described as Stropharia cyanescens by William Alfonso Murrell in Florida. But there's also another history. There's a cultural use. It's a little bit difficult diving way back into time, but we can start to look at cultural use in a little bit more of a modern context. In 1915, Safford identified Tanana cattle as peyote, feeling that indigenous peoples did not have good enough mycological understanding or knowledge to be able to identify and use mushrooms. A little bit of a colonial kind of attitude. But then in 1923, anthropologist Blas Rico learnt of mushroom ceremonies in Oaxaca, and that they were being used traditionally. In 1936, Robert Whitelaner managed to observe the ceremony and was also able to collect samples that he then sent on to Rico that were then deposited. These at the time were identified as Paniolas, but these specimens were then re-identified later on as Psilocybe mexicana. In 1939, Richard Evan Schultes confirmed Tanana cattle as a mushroom with ongoing traditional use. Referring back to the original passages by the priest Sahagan back in the 1500s, when he was writing about how the indigenous peoples were using mushrooms as part of their religious or spiritual rites. In 1948, Rolf Singer confirmed some of Schultes' collections were indeed Stropharia cubensis. But those specimens were specimens that apparently he went off, he and Blas Rico, who had gone to Oaxaca together, had obtained mushrooms from some of the indigenous peoples. But one morning, Schultes went off by himself and collected a group of mushrooms from the field, and these were the mushrooms that he'd collected. He managed to come across Stropharia cubensis. And this photo here on the right-hand side is of Richard Evan Schultes amongst a group of Mazatec peoples. Seeking the magic mushroom. All these stories were being published in academic papers and eventually reached Valentina Wasson through the poet, I can't remember his name. Will it come to me? Probably not. We'll add it later. But Valentina Wasson received these copies of these papers talking about mushroom ceremonies in Oaxaca and passed them on to her husband, Gordon Wasson. The two at the time were writing their book, Mushrooms, Russia and History. And we're looking for examples of the use of mushrooms in mushroom ceremonies. So of course they were fascinated.
Testing. I'm afraid so. I'm going to find you a mic stand, but you're just going to have to hold it for a minute.
Mic stand just there.
Where?
To your right.
Okay, where do I need to start again? Go back three slides. Really? Yes. Go back 3 slides. I can do that. Please. Thanks for your patience. Okay, we good? Okay. Where do I start from?
Back 3 slides.
3 slides. Two slides at least. We don't know, so two slides. Okay, so we don't have anyone who can give us Don't
a...
wave without watching the screen, okay?
All right.
Okay, we're good to go? Okay, sorry everyone. There's been a few technical problems going on. I'm going to start again from this slide. So history, so the cultural use. It's hard to actually get a history of the full cultural use. It's kind of, a lot of this is lost in time. It's lost in verbal and non-written communication. So we kind of need to then fall back on some of academic resources. But then we can, so as of like 1915, there was academic Safford who identified T. ananacatl as peyote, the peyote cactus, which is examples of it here on the right-hand side here. He felt that Indigenous peoples didn't have a good enough mycological understanding, a good enough knowledge of fungi to be able to identify and use these mushrooms in the way that was being recorded by people, by people like Sahagan, for example. In 1923, Blas Rico, anthropologist, learnt of mushroom ceremonies and that they were being used traditionally in Oaxaca. In 1936, Robert Whitelana managed to observe a ceremony. He was able to collect some samples from some Indigenous people, and he then sent those on to Rico, and then they were submitted to a herbarium. In 1938, Blas Rico and Schultes travelled to Oaxaca. Then in 1939, Schultes confirmed T. ananacatl as a mushroom with an ongoing traditional use. And this is Richard Evan Schultes here on the right-hand side of this photograph amongst a group of Indigenous Mazatec people. In 1948, Rolf Singer confirmed that some of Schultes' collection were indeed Stropharia cubensis. We then have this period where Gordon Wasson and his wife Valentina were travelling to Oaxaca in order to try to find examples of mushrooms being used in ceremony. So in 1955, Valentina Wasson and Gordon Wasson were the first known European Americans to actively participate in an Indigenous mushroom ceremony. At the time, they were both writing their book, Mushrooms, Russia and History. And Valentina Wasson had been in contact with the poet Robert Graves, who had passed on this information, particularly the paper by Richard Evans Schultes, discussing the ongoing use of mushrooms actively in ceremony. So they both travelled to Oaxaca in order to participate. In 1956, they were joined by the mycologist Roger Caine, who identified the psychoactive mushrooms as from the genus Psilocybe. In 1957, Gordon Wasson published his article in Life magazine, Seeking the Magic Mushroom, and a week later, in This Week magazine, Valentina published her article, Ate the Sacred Mushroom. Examples of the mushrooms had been passed on to chemist Albert Hofmann, who in 1958 identified that psilocybin and psilocin were the active compounds. This is a scan of the inlay from Gordon Wasson's article, showing the mushrooms that were being found by Roger Caine. So these were drawn and coloured by him, and then printed within the article. But you can see here on the bottom right-hand corner we have Psilocybe cubensis. Recent taxonomy. Singer in 1948 moved Psilocybe cubensis from Stropharia to Psilocybe, intersection Caerulensis. And then in 1958, Singer and Smith revisited Psilocybe and went through and divided it up into sections, and then also looked at cubensis. And they split Psilocybe cubensis up into 3 different varieties. So var cubensis, which is the type species, described as having a reddish yellow tawny cap. The var cyanescens, which lacked pigment, with a cap that was pale to pale grey yellow, known from Florida. And then var caerulensis, where the cap was yellow, and at least in certain and known from Southeast Asia. Guzman then did a whole reanalysis of the genus in 1983, publishing his results as a book, The Genus Psilocybe. So within the genus Psilocybe, he moved Cubensis into section Cubensae, and decided not to recognise the varieties of Singer and Smith, because essentially these varieties were all based on the colour. And as been shown in many of the photographs already this evening, you can see that the hygrophanous cap, it changes colour over time. So Guzman felt that this was not enough reason to then be able to break Cubensis up into varieties. Based it was just simple colour change of the cap. History in Australia. It's important to begin this by noting that there are no recorded traditional consumption or taboo relating to Psilocybe species by First Nations Australians. We would expect that Psilocybe cubensis was introduced by cattle, and it has been noted possibly as early as the First Fleet, given that some of the cattle in the First Fleet were apparently collected in South Africa and also India. The first recorded specimen from Psilocybe was Psilocybe semilanceata by McAlpin in 1895. And semilanceata is also an introduced species and also spread with sheep, so another introduced livestock. In Cleland's book, published in 1934, he notes some species of toadstool give rise to a kind of intoxication, noting the mushrooms ingested
were probably a dung-inhabiting species. Cleland mentions a story by a colleague whose relatives accidentally included a misidentified fungus within their meal. So Cleland goes on to describe this as the meal progressed, they gradually became more and more hilarious, the most simple remark giving rise to peals of laughter. The intoxication passed off without any unpleasant effects. I'm sure there are some people in the audience who may relate to this story. There have been some case studies published over time. Psilocybe cubensis may have been responsible for a number of poisonings reported in case studies by Trotter in 1944 and by Stocks in 1963. Aberdeen and Jones in 1958 published a hallucinogenic toadstool in the Australian Journal of Science. They were actually looking for a Paniola species, but then going through the literature and looking at the distribution, ended up concluding that the hallucinogenic toadstool was most likely Psilocybe cubensis. And they went on to describe the distribution of Psilocybe cubensis across southeast Queensland, including Springbok and then northern New South Wales. Later in the 1960s, magic mushrooms hit the news. First of all in the Sydney Sunday Telegraph, and then shortly afterwards in the Canberra Times, and then also in the Canberra Times a day later, with titles such as "The mushrooms contain drug" and "Unwanted tourists," with reports of people jumping fences in order to collect magic mushrooms. The news stories continue. Many taking a trip on Hill's mushrooms. This article is specifically about Psilocybe aeruginosa, but then we also have the Daily Telegraph on the right hand side here, pupils getting high on gold tops. But what are the origins of the countercultural knowledge? It's assumed to be surfers or hippies visiting from California or other parts of the United States. McCarthy in 1971 published an article and had this to say: for some time, young drug users had been aware of the existence of a legendary mushroom, but information regarding habitat identification and effects were lacking. It seems that the necessary information was supplied by a visiting surfer from New Zealand or the USA. We could probably guess that many people were aware of the mushroom and knew what it was and knew how to identify it. But in order for a wider distribution of this knowledge, maybe we needed some help from visiting counterculturalists. The story was well and truly out by the 1980s. So this article from Australian Natural History, Mushrooms, Poisonous, Edible, Hallucinogenic by Tim Lowe, who describes the use of gold top mushrooms as the most widely eaten of all mind-altering fungi. But he also notes that there are amateur mycologists who know more about these species than the scientists, citing P. colobioides, which we now know is probably Psilocybe aeruginosa, especially given the fact that it was found in a fridge in Tasmania. Times have changed. What was seen as a recreational drug that was being used in non-clinical settings for non-clinical use, this perception is now changing. So with thanks to our friend Alistair McTaggart, who managed to obtain a permit to collect and study psilocybe in Queensland, our understanding of cubensis in Australia has changed somewhat, as our understanding of Psilocybe aeruginosa. Reset Sciences in WA and Funky Fungus in Queensland have attained a permit to cultivate. So things are happening, things are moving. Globally, the Oregon Psilocybin Advisory Board recommended that Psilocybe cubensis be the sole taxon gone for commercially producing psilocybin, in part because of the whole scare factor around woodlovers' paralysis, which some of us may feel is a little unfortunate. Decriminalisation and permits, changing in laws across the planet are now allowing new research. There's been some fascinating papers coming out, and they're coming out quite quickly. It's great to see. I'm going to dive into cultivation history now. So Psilocybe cubensis, so the early days. So cubensis was first cultivated in 1957 by Roger Heim and his colleague Caillou, who cultivated various species of Psilocybe, including Psilocybe mexicana and Psilocybe cubensis. These were cultivated from spores collected in Oaxaca and then grown on rice. I'll leave it to those of you in the audience to see if you can identify the mushrooms here on the right-hand side. Another notable paper was in 1964 by Cutelfomo and Tyler, who published a paper about growing psilocybe within liquid culture. In 1968, the growing interest in the counterculture led to the beginning of a publication of numerous small books. The first of these being The Psychedelic Guide to the Preparation of the Eucharist in 1968 by Robert E. Brown and Associates, with this absolutely stunning cover. And then a description of how to grow on agar, and then how to grow mycelium in liquid culture, and suggesting that you don't really even need to grow the mushroom, you could possibly just use the mycelium itself. In 1971 in Mycologists, J.P. San Antonio published a paper on cased rye grain, and things started changing. But before that, in 1970, Leonard Enos published this gorgeous little book, Key to the American Psilocybin Mushroom, that also describes cultivation. Then in 1972, Gould, Field Guide to the Psilocybin Mushroom, with a very, very brief description of growing on agar, and then on grains or rice. 1976, the classic book by Austin Eric, illustrated by Cat, Psilocybin Magic Mushroom Growers Guide was released, and things really started to step up. This is a beautiful book, really well written, and the instructions are fantastic. In 1977, Jewel Stevens and Rich G published How to Identify and Grow Psilocybin Mushrooms. This is also an important book, and I will come back to Rich G shortly. 1977, Richard Pollock published Magic Mushroom Cultivation. The level of professionalism stepped up. 1978, Ott and Bigwood published 10 Nanocattle Hallucinogenic Mushrooms of North America. This is a highly recommended book to have. It has how to cultivate, but also some really lovely taxonomic descriptions as well. In 1984, The Mushroom Cultivator was published by Stamets and Chilton. 1986 saw the revised edition of Olsen Eric. And then by the 90s, mail order spores had become pretty popular. You could buy High Times magazine, and within the back section, there was just countless advertisements of where you could purchase spores. And then also in the early 90s, the PF Tech was published by Psilocybe fanaticus. And this beautiful tech allowed people just to grow mushrooms at a really, really basic, easy level with moderately okay yields. In 1992, even the fabulous Ferry Creek brothers described how to cultivate P. cubensis. Fortunately, we never saw the mutant psychedelic fungus overrunning cities, fortunately. This is the PF Tech. It's essentially a technique using brown rice flour and vermiculite. It's all used to make a little cake that was then steamed. Spores were injected. These spores germinated, myceliated the cake. When they were fully colonised, you could take out the cake, place it in a shotgun fruiting terrarium, and within a week, 2 weeks, mushrooms started to produce. You could harvest, spore print, and repeat the cycle. Heading into the 2000s and into now, the beginning of the 2000s saw online communities emerge. So the Shroomery, Mycotopia, incredible resources and incredible discussions that just saw this whole countercultural citizen science community just really step up to the game. In 2006, we saw Nicholas and Ogami's Psilocybe mushroom handbook on easy indoor and outdoor cultivation. And then in 2016, Hayes and Mandrake released the Psilocybe mushroom Bible. Things have stepped up even further, and we now have online courses if you're keen to learn how to grow and be able to grow your own mushrooms. So groups like Double Blind, Third Wave, and others have online courses that you can join and learn how to grow your own Cubensis. And here's just a review of some of the books over time. History of cultures. There is an abundance of names of particular strains. The first strains, which is what we refer to, how we refer to as types of Cubensis that have been found either in locales or they've been bred to a point where they become stable in a particular form. But the first strains were likely just named after the locales they were found, so Amazonian, Cambodian, Ecuador, Puerto Rican, etc. Then with increased interest and sharing of interesting variations and mutations, more interesting strains appeared. P. envy being one of those. So the P. envy line has gone in a very interesting direction. Many of the modern strains push for potency, but then there's also a lot of growers just creating things that are really beautiful, really interesting looking mushrooms, focusing on mutants or things that just are really, really pretty. On the right-hand side here are a number of the strains that we used in the analysis that were included in Alistair's recent analysis. And you've already seen this chart this evening, so I won't go into too much detail, but we can see here that Alistair et al. Have broken up these strains into different populations. Well, they've kind of separated out by themselves. So we have Australia here on the left-hand side, but then we have the other groupings of Golden Teacher, P. envy, Maladar, Luminous, and Blue Magnolia. Golden Teacher first appeared in the early 1980s and appears to have been one of the most popular of all the strains. It was originally thought to be from Florida in the late 70s or early 80s, but this is unconfirmed. Strains derived from Golden Teacher include True Albino Teacher, White Rabbit, Yeti, Cubensis, Golden Emperor, and Golden Halo. Other strains that may have also been bred with or derived from include Avery's Albino, B+, Burma, Cambodia, and McKenna, Aricia, India, etc. So you can see Golden Teacher forms the basis of a lot of the strains that we have out there within the community. And this is just some examples of Golden Teacher. We also have the P. envy line. So legend was that Stephen Pollock was responsible for penis envy, but this is not true. Hamilton Morris interviewed mycologist Richard G., which you might remember from a few slides back with a book that he co-wrote with J. Stevens. And he was identified as the person who bred the P. envy strain. So the book Cubensis Aquarium Gardening, published in 1995, contains the first recorded photograph of the P. envy strain. It was developed from dried Cubensis, said to have come from an old Amazonian strain collected by Dennis and Terence McKenna during their Amazonian adventure. We then have the blue magnolia population and its association with A+ and B+ strains. So these are the strains that are included within that blue magnolia population. So A+, albino A+, blue magnolia rust, golden teacher Denver, Koa Samui, which is a Thai strain, and Mexican Dutch King. It's suggested that both A+ and B+ originated from an amateur mycologist named Mr. G, based in either Florida or Georgia. He has a bit of a reputation, and some of his theories are not necessarily correct. B+ originally sold as a Cubensis azurescens hybrid, which we know is not possible. But he was convinced that they were he'd done that, and that he'd genetically combined these two very, very different species. Of note of late are strains such as Tidal Wave and Enigma. Tidal Wave is a hybrid of P. envy and B+. It currently holds the record of the strongest strain of Psilocybe cubensis at 3.8% total tryptamines by dry weight, which is a ridiculous amount. Enigma, referred to as a blob mutation, comes from Tidal Wave. It appears as a blob-like clustering of mycelial bodies, as you can see here in the photo on the right-hand side, and it doesn't produce gills. It exists only through clonal cultures. Pharmacology. The active compounds include psilocybin, which is the prodrug for psilocin. Other compounds include norbaeocystin, baeocystin, norpsilocin, and erigenesin. Consumption of this mushroom, as per some of the reports that I've included within this presentation, often results in psychoactive effects commonly associated with the classical psychedelics. The effects include sensory changes that may be visual, auditory, and or tactile. An altered sense of time and space and feelings of euphoria are common. Here are some of the reported amounts of psilocybin and psilocin over time in various papers. So Haim and Hoffman, so 0.5% psilocybin and 0.25% psilocin. Other samples included 0.15% of psilocybin and 0.5% or 0.33%. Gartz found 0.63% psilocybin and only 0.11% psilocin. And Tsujikawa, which was probably the most cited paper up until recently with respect to the concentration of psilocybin and psilocin in Cubensis, the 0.37 to 1.3% psilocybin versus 0.14 to 0.42% psilocin. This is the biosynthetic pathway of psilocybin proposed by Agurel and Nilsson. So it's proposed that psilocybin or psilocin begin with tryptophan, which is then converted to tryptamine, then N-methyltryptamine, then NN-dimethyltryptamine to psilocin, and then finally to psilocybin. Before I finish up, I'm going to talk about some lookalikes. There are quite a few. Of note recently, in going through iNaturalist records and knowing that Amanita sect Phalloidae do occur in Australia and also occur in southeast Queensland and northern New South Wales, this is possibly of note as they may occur in similar habitats. It's worthwhile knowing, and it's worthwhile being able to identify these species. but other lookalikes include Stropharia species, so Stropharia coronilla, but then also Agrosabe species, so Agrosabe pediatus, then Candoliomyces candolianus, Bulbitius titubans, Protostropharia semiglobata, but then also some Diconica species for smaller specimens. And just to wrap up, some resources if you're interested. So books, Mushroom Cultivator by Stamets and Chilton is fantastic. Lots of information on growing numerous species, including those included in tonight's presentation. Other books like Stamets, Tradcotter, and also Peter McCoy are also useful. Websites include shroomery.org and then also mycotopia.net. And that's me. So thank you, EGA, for having me. And I believe for now we're having
All right, thanks.
a short video.
Yeah, we're going to play a short video in a minute. Thanks everyone for staying with us. It's been a pretty crazy night. We're at Harm Reduction Victoria today, so yeah, it's a new space that we're trying out. Hopefully with the idea of having in-person events here shortly. But we'll see how we go. Got to get everything running smoothly first. Thanks again, Nick. Sorry, Caine. How many talks have you given for EGA over the years?
A lot.
Caine? A lot.
I've lost count.
Yeah, too many. Not enough. Not enough. I'm going to say not enough.
There are more.
There are more. That was very
But
impressive.
not tonight.
That was very impressive. I didn't get to see every slide and every part of your talk, but as always, absolutely fantastic. Absolute privilege. I've had the privilege of working with you for many years. We'll just see where that video is at.
It's ready.
It's ready.
Here it goes.
Here it goes. All right.
Thank you, everyone.
Do not eat death caps.
Do not eat death caps.
Do not eat death caps. No. What was it? What was it? What was the food?
Hello, my name is Caine Barlow. I'm a mycologist and fungi educator. I really enjoy sharing knowledge about fungi. They're incredible organisms, they're really quite fundamental to our ecology, and they're just beautiful, fascinating organisms. We've been lucky enough to find Amanita phalloides. This is the death cap. This is a very, very poisonous mushroom. It grows in a mycorrhizal symbiosis with oak trees, and you can see all the oak trees here scattered around it. It sometimes does get confused with edible species, particularly the straw mushroom. So here we have the vulva. So this is the remnants of the universal veil. This is the membrane that encloses the entire mushroom as it develops from its primordial state. As it grows, the cap and the stem expand and breaks free from this membrane, leaving this cup-like structure. In some cases, this gets washed away in some amanitas, so even though it may have had a vulva, it's no longer present. The stem will expand, the cap will then open, and the partial veil that's protecting the gills will then fall away, leaving the partial veil, which is also termed the annulus or the skirt. This is the cap. You can see that kind of yellow that's becoming kind of ever so slightly olive green. And underneath we have the gills, which are this kind of white, slightly creamy, yellowy colour. And if we were to look right up underneath, we would see that the gills have a free attachment. So we can see in the reflection here, we have the vulva, which is the remnant of the universal veil. Further up the stipe, you can see the annulus, which is the remnants of the partial veil. And then we have the cap, the pileus, which is this kind of yellow colour, slightly turning green colour. You can see the gills have this beautiful kind of white to slightly cream colour that is typical of Amanita. Learning to identify fungi is daunting to begin with. There are new words to learn and a new visual language to take in as you learn the features. I would like to thank you for watching this video. If you're interested in knowing more about some of the species mentioned, there are a number of useful videos in the Entheogenesis YouTube channel. Thank you again for watching.
Well, thank you very much, Caine, and thank you very much, pre-recorded Caine. Always good to have a couple of you in our back pocket. Thanks everyone for sticking with us for tonight's live stream. Slightly more experimental, but experimental for a reason, and that's because, geez, do you reckon you could pan that third camera around for a moment? Is there somebody that I could jump on there? Okay, so we're just gonna jump on people in action. So we've got a bemused looking Caine, but I just want to show you, so there's another camera there. It's a bit gloomier, but if you pan it around, the black magic one. Which one is that? Oh yeah, that one. Yeah, pan that one around, and zoom out if there's a zoom out. Oh, there's running, sitting there. I just want to give you a scope. This is a former ballet studio. So it's quite a big space and it's quite empty right now. So we'd love in the future to see your faces instead of your display names for those that are local anyway. So you can come join us and we can have some chats afterwards. We can get some food and drinks, and we can continue to offer the live stream as well, but we can also offer some live interaction because it's been a while. And hey, oh, there we go. Ooh, that's done that thing that it does where it's not happy with my, no, it's not gonna, I don't like that. All right, so we're gonna get into some Q&A. So Q&A. Thank you very much to everyone who has asked those questions, and don't forget as well that if you want to continue these conversations, if you want to keep being involved with the broader conversations and on other entheogenic topics, go to the website and hit subscribe, and you can stay up to date with all the updates from EGA, and make sure that you're seeing all the resources as they come out, and all of the and all of the everything else that comes out from EGA. There are lots of fantastic things going on, so I'm trying to do a couple of things at once, but hey, there we go. And I'm just going to oh, that's too small for me. All right, let's go to a question.
Nick, you might want to let Alistair and Simon.
Yep, I've got him.
You've got Alistair, that's the main one. He's got the first question.
Okay.
Yeah, we have Alistair.
Oh, hey. Okay, I'm going to give them some audio in just a moment, and I'm going to find my first question. Hey, this one's directed to Alistair. It is, how far can spores spread themselves naturally? Thank you, Hectech FPV. And Alistair, have we got you there? Oh, no, we've got an empty chair. Oh dear. Let's ask another question for someone else.
Alistair's back.
Alistair, I've got a question for you. And that question, how far can spores spread themselves naturally? And that's from Hectech FPV. Thank you for your question in the comments section. And when you're ready, Alistair. Oh, God, you can't hear me, can you?
Alistair's on mute. I think Alistair's on mute. Oh, he's back.
I'm just trying to find which mouse I'm looking at.
I love you guys. It's like a flashback in a simulacrum.
Okay. And for a third time lucky, Alistair, how far can spores spread themselves naturally? Isn't it? Oh, hang on. Why does it do that?
Spores do get out there, but when you've got valleys or whatever and the wind currents can't get past things, then I guess those are the limits to geographic spread. I don't know, because in the subpopulation we do have less evidence of contemporary gene flow. That kind of answers that, and these island populations, it sort of answers that they aren't fully getting out among each other. I don't know. I'm not sure if that was the context of the question. Hopefully that shed some light on it. I don't know.
Yeah, I did see it pop by in the comment section, and I don't think there was much more context around it that I noticed. I think there was just looking for that, and I imagine it's different for all the species there. Sorry, every time I plug something in, it turns something off on me, which is all right, more questions.
Just to jump in there. Can I jump in there?
Of course.
But then by naturally, do we also include animal distribution as well? I mean, humans and other animals will also distribute spores quite a long way. So I feel like that can be part of the equation as well.
For Simon now, would you recommend combining bee carpy with psilocybin for a mushroom journey, with the acknowledgement and dose adjustments taken into consideration? Psychedelically aware asking that question. Oh, yeah. Would you recommend combining bee carpy for a mushroom journey, Simon? With the acknowledgement and dose adjustments taken into consideration, and that question comes from Psychedelically Aware.
I'm not going to recommend anybody take mushrooms for anything ever, but I think the thing to remember is that the bee cappy is going to have some monoamine oxidase inhibitors in it that's going to potentially potentiate the psilocybin effects. It inhibits one of the breakdown pathways for that, and it has its own, the harmalas that are in the cappy vine have their own biological effects as well. Some people find them quite interesting just on their own. So I'd just say combinations are best left to people with some experience with both of the things that they're planning to combine together to change an experience, and to do some research and look at. There's plenty of reports and stuff like this from online that you can find, where people have combined all sorts of different things on like Erowid and other forums. So suss out what other people have experienced as well in advance. And if you are going to combine two different things together, especially if there's a possibility that they will potentiate them, you need to start extra slow with low doses of both of the both of the things you're going to combine, and work your way up while you're getting more familiar with them.
Might be a good point here to also point people to the EGA entheogenic combination matrix, which is a resource available there on the EGA website, and has had some recent updates with some more detailed information about what to expect from certain combinations, because first and foremost, there is still a prohibition in play. You are putting yourself at legal risk by taking prohibited substances, but that taken into consideration, the various different effects of chemicals can change in combination, and if you are thinking of doing anything like that, then do try and find some information about any kind of interactions between those things. Caine, what's the earliest cube specimen submitted to the Australian Herbarium from Darklight?
Okay, so the earliest specimen submitted to a herbarium in Australia was to Queensland Department of Environment and Science on the 1st of April 1952. And no, that wasn't a April Fool's joke by the looks of it. but there were also a number submitted that year. So, and then after 1952, then the most recent was 1960 and 63, all submitted in Queensland.
Thank you, Caine. This question for Alistair. The question is sexual compatibility the main benchmark used for defining a species? Thank you, Graham Bushell, for that question.
Graham, what a great question. And whoa, it is kind of like a university thing that professors ask their students, what is a species? And nobody really has an answer because nobody knows what they are. Essentially, you could think of species as functional populations. And so you'll have populations of an organism that can reproduce sexually. And then over space and time, those populations become separated and lose mating compatibility. The problem is with mushrooms, because they're of their mating compatibility system, differences benefit recombination because you have to differ at these mat loci. So you can have allopatric speciation, as in two different populations in different parts of the world who never ever get to see each other, but they haven't evolved to not be compatible, so they can still cross. And yeah, it's a how long is a piece of string kind of thing. So geneticists probably look at, or taxonomists or whoever's looking at species, are looking at evidence of gene flow, evidence of a lack of gene flow, or sexual compatibility should be one of them. And then often people just look at hundreds of genes. I think in that Carimbia thing I was talking about, it's really just random parts of the genome to resolve a phylogenetic tree. And people will often just draw the line somewhere. And depending on who you are, you'll draw the, the bullseye around the arrow, or whatever you want. There's some subjectivity to it, believe it or not.
I feel a little bit like there's some things on show that when we first did this, had a lot of time to work out how to do all of these things, and suddenly all of that time has been sapped up. But this is a good test. I know some things. I've got some things to fix when I go home. For Caine, Cubensis present on the coastal south coast of New South Wales from Matteo R. And actually, I'm pretty interested in that one as well, because I noticed that around the Great Southern Arc in far east Gippsland, you have a pretty significant change in the environment. It turns much more into sort of a rainforesty environment from the as you head further up east. So yeah, do you know anything about this, Caine?
All I know is that they occur as far south as Kiama. This again is really the kind of thing that would be really helped out by people who are finding Cubensis in these kind of more southern locations, to make iNaturalist reports, and so that, or even on some of the Facebook groups, for example, PMANZ, for example, or Psilocybe or other groups, so that we're aware of this. But Cubensis are a subtropical species, so I guess to be finding them further and further south, you're starting to look at then adaptation to cold environments and environments that are drier and don't have that same kind of humidity that they need to be able to grow. So that's all I know. If you're finding them any further south, anyone out there in the community, please make a record on iNaturalist, or just send photos and a record to a Facebook group.
I can give some first-hand experience that was unfruitful from around the Bega Valley area, almost as far south as you can go in New South Wales, for either varieties, although I wasn't as familiar with Cubensis identification. at that time, so I was probably not looking for those signs, more the other signs. But yes, I didn't. That wasn't something that I came across. So yeah, I did absolutely something that, you know, if you do, document. You are a citizen scientist. This one for Alistair. Have you seen sporeless Cubensis in the wild? Thank you, Sienna Rose, for that.
Oh, Sienna, what another great question. I've not ever encountered this, and if you were going to have that, it would have to be really, really interesting. Essentially, it would be a non-propagating genotype, and the way that we understand cubes to work is that you have ephemeral genotypes over time. So a cow eats the spore off a piece of grass, spores meet up in a nitrogen-rich manure. That genotype fruits after this mycelium colonizes the manure. Mushrooms fruit, they're all the same genotype, probably out of that manure. But once that manure is gone, that dikaryotic mycelium is gone. And if you've just produced a mushroom that doesn't have spores, you need to exist clonally. And cubes don't exist clonally, to my knowledge, really outside of people sharing cultures. So when you've got a sporeless cube, it's probably the result of a lot of inbreeding to start tinkering with sexual reproduction or something along those lines, or sporogenesis, and yeah, some sort of homozygosity based on inbreeding. So I don't think they'd occur in the wild. If they do, it'd be a freak of nature, and it would have a dramatic cul-de-sac of evolution. Cul-de-sac, whatever the plural is.
I can add to that as well, in that they are found every now and then. People do make records, certainly on the Facebook groups of species that are sporeless. So even like in just the last few weeks, I've seen a couple that have very, very white gills, so they're either sporeless or they're true albinos. Now the thing with true albinos is that the pigmentation also doesn't occur in the spores. So it's actually very hard to see the spores when you do print them out. You kind of have to scrape it up and look at it under a microscope. But they do happen. Yeah, and then as Alistair said, it's just like, otherwise, yes, they just won't continue existing in nature, and yeah. But they're the kind of thing that are quite desirable in the underground at the moment with people who love to grow out Cubensis. They're looking for those kind of genetic traits.
Okay, this one's for Simon. Simon, due to the increased strength of the lemon tech method, do you think it's a good idea, good side method for the first time users over the more traditional powdered mushrooms?
I think, like in my little talk, I was saying the better way to approach any new method that you're going to ingest a mushroom by is to get familiar with the batch that you've got in front of you, and to always start low and go slow. So if there's a particular dose range you're going to be aiming for, and you're not too sure what the potency of your batch of mushrooms or mushroom tea in front of you is, shoot under. You can always take a little bit more, even though that doesn't necessarily sort of amplify the experience with mushrooms, within much of a window of the first dose. But it's still better to undershoot than overshoot, and you can always come back and try it again later. But if you've made up multiple doses into a single batch, just start lower, and with the lemon tech, or even just any other sort of aqueous extract, if you start a little bit lower than you might when you're eating the mushrooms, especially until you're familiar with the different methods, it's going to be the safest way to go.
Yeah, and I'll just reiterate that start low, go slow is pretty good advice generally for most things, because it's much harder to get out of something that you've thrown yourself into the deep end of than getting out of the kiddie pool. Alistair, for you, what is the evolutionary purpose? I saw this one pop up, and I think we've touched on it. We touched on it a little bit, but the evolutionary purpose of psilocybin. Can we predict what the next arms race will be in favour or against it, neurologically speaking, from Darklight? particularly interested in this one.
Bless you, Darklight. I wish I knew the answer to your question, and I'm sure everybody wishes they knew. I guess what I was talking about in my talk was just that, attractant, repellent, or does it take control of minds, which is what we know secondary metabolites in fungi do. And yeah, romantically, it's so nice to think of them as being, geared towards taking control of something, or three-dimensional chess, but usually I kind of go, okay, it's whatever. It's the poison to stop something from eating it. I don't know. In terms of the next arms race, yeah, I absolutely think it's going to be humans innovating with it. This way we domesticate absolutely any organism that's beneficial to us. So it'll hopefully will just be in the designer shroom space, making the perfect combinations of alleles that fit so snug with combinations of tryptamines in mushrooms.
Yeah, I think this is one of those. It's one of those good to ponder questions when maybe the mushrooms are guiding your thoughts. Our next question for Caine, we think, when P. cubensis grow in the wild, is summer with high humidity what environmental circumstances we're looking for?
Yes, summer with high humidity is good, but also summer with high humidity and lots of rain is better. You want your soil to be well drenched with lots of moisture. Mushrooms are like 80 to 90% moisture, so they need to soak up a lot of water to then be able to fill their cells to enlarge the mushrooms. And the humidity is necessary in order to then to stop the mushrooms from not drying out before they're able to grow large enough to be able to then distribute their spores. So summer with high humidity is good, but also you want lots of rain, and if you're trying to seek out habitats, then look for somewhere that's moist, where the ground is moist and you've got high humidity.
This one is for Simon. I am in the corner now. Are there any rumours, talk of law reform now that it has medical status? Who has the authority to produce them for medical purposes from cosmic kaleidoscope? I also might be able to chime in on that, but Simon.
Yeah, look, in terms of the second half of the question, Alistair probably seems like he's in a better position to answer it than me now. I wouldn't have a clue. I think last I heard, we were still planning to be importing most of the psilocybin that was going to be used clinically at the moment, that I don't think any doses have been administered clinically in Australia yet. Could be wrong on that. It's changing really quickly, but don't think we're actually at that point just yet with the psilocybin. And in terms of law reform, unfortunately, I think what Canberra, New South Wales and Queensland probably now feel like they've done enough with the fairly minimal changes they have made to some of their drug laws. New South Wales is still planning to have a drugs summit, which seems like an political move to me, given that they had the ICE inquiry with a pretty comprehensive amount of evidence provided to them from health experts and community groups and everybody who has some knowledge about this and should be heard on the subject. And none of those recommendations have been implemented yet. So I'm not expecting it to happen anytime in the near future, but I think there are changes in the works and things are moving and stigma is dropping and more people are using these things and more benefits being shown and less harms being sort of demonstrated. It's getting harder and harder to push the existing narrative around particularly psychedelics and, to some extent some other drugs as well, and also just more broadly pushing the narrative that the drug laws are effective or helpful in any way is becoming a harder sell, I think. So yeah, fingers crossed and hopefully, but I think the best way to do it is to get involved in public advocacy and write to your local members of parliament and your federal government and let them know that you want to see these things change, because until it's a politically safe thing to do, there's not really any reason to do it. You know, there's still talking about a fairly small demographic of the population at the moment who are interested in these things. It is not really a big voting issue. And because of the laws and their very nature, I think it's a silent minority as well. And the more noise that gets made, the more likely it is to shift.
Yeah, and much of that is reflected in Victoria as well, where we had an inquiry, a wide-ranging inquiry that had 50 recommendations. I think a small number of them have been partly applied here in Victoria, but it has moved very slow. Even the fact that people who are prescribed cannabis can still, regardless of the fact that they're not impaired driving, they will still test positive on that on those devices. And as the law stands, that's all that's required to charge somebody. It's not about impairment, and it's not about whether or not you have a prescription, which seems particularly absurd. So there's probably smaller fish to fry at the moment. But that said, there are only a small handful of people every year here in Victoria. I'm not sure about other states, but I would say that it's pretty similar. Maybe with the exception of WA, when that little pocket of community, I can't remember, Ballingsworth? I'll have to go and look it up later. That got a lot of police attention. But generally there's less than a dozen people who are charged with psilocybin-based offences in any given year. It's a small number, and it's on the books, so it is possible. And for those that it does happen to, it can be devastating. So we want to absolutely get rid of it. But it's not something that Victoria Police are particularly focused on, and I suspect that's the same in New South Wales, unless somebody somewhere does something stupid, which that's a guarantee as well. That will always happen as well. Okay, our next question. Caine, what is the limiting step for psilocybin production in psilocybe species? Thank you, Darklight. Your winning questioner at the moment.
Okay, so the limiting step. The limiting step is the substrate. It's the quality of the substrate. This is something that you will definitely see, say, for example, with Psilocybe seborrheicosa. If it's growing out in the forest and it's just growing off a few kind of, idle wood chips and amongst soil, it doesn't have access to a lot of the stuff that it needs to then be able to grow, to make psilocybin, compared to, say, wood chip seborrheicosa, which can be incredibly potent, insanely potent. So substrate is really probably the main thing that you want to be looking at when you're thinking about psilocybin production. Beyond that, you could probably then also say dose your substrate. I know various researchers have experimented with this in the past with applying different compounds in different substrates and seeing what happens. Jochin Gartz is one of those, and some of his research is quite interesting to look into. You're probably looking then at things like the amount of nitrogen that's present, the amount of L-tryptophan that's also present within a given substrate. So, but if you're growing on rice, you're going to get some psilocybin. But if you're growing then on rice with gypsum or dung and straw, you're going to really upgrade your psilocybin content. And in fact, there was a new paper that's only been published, I think, a few weeks ago, coming out of the field trip group that they've shown that adding gypsum, for example, really pushes the amount of psilocybin and total tryptamines up quite a bit.
Thank you, Caine. Just moving something around because it was bothering me. Oh, now that's disappeared again. Thank you, everyone. We're just about just about to wrap up our webcast for tonight. Thank you for your questions and your engagement. So we've got a couple of last questions. I'm going to just put this up because I can't actually see that I need, and you don't normally see all this stuff because I like to hide it away. Ballingup, thank you, Caine. Ballingup in WA was the location. There is a little documentary that we actually screened out in Belgrave a few years back that I just found the solid state drive that has it on it after moving house and losing things in convenient locations for far too long. Yeah, Ballingup, it got a bit of a... I mean, it's often the story. We've seen it recently with the incidents, medical incidents that happened at a festival at Flemington Racecourse, and solely because of that attention, a festival that was rated low risk by most of the authorities had to have, according to higher ups, far more police attention, even though it wasn't required and was arguably, and pretty fairly arguably, a waste of resources, because the media's eye was on it, because the public's eye was on it, and that's something you generally want to avoid if you're not really doing something wrong, hurting people, stealing things, whatever. So thanks again to everyone for those questions tonight. And we've got a couple of last ones to go around the group here. Oh, is that the last one, Ronnie?
That's the last question. Yeah, last question.
There is a last one?
That's it, around the room.
Around the room.
Yeah, the last question is what each of them hope for in their space to change.
Oh, sorry. There's a lack of punctuation in there. Around the room for what? I thought it was a run-on sentence. What are your hopes for the near future in this space? This is a good one to end on. Okay, this is our generic sort of ending question. But Simon, since you're on the screen, we'll start with you. Simon, what are you hoping to see over the next, let's say, 5 years?
From my perspective, in the mental health space, I would like to see more recognition of their potential use as a wellness enhancer and illness preventer, rather than waiting until using it at the very end of a treatment cascade. I'd like to see them become more accessible in the clinical space, price and availability wise. And I think I'd really like to see some legal change that recognises realistic relative harms and the fact that the current drug legislation causes, in my opinion, a lot more harm than it solves. In fact, I think it only really serves to cause extra harm.
Yeah, no, that's objective, I think.
yeah. So to me, those are the main things. Yeah.
Okay, Alistair, over to you. Next 5 years, what are you hoping to see?
Oh man, Simon's hopes were so good. What I would hope for is that, plus people get to experience some of the heterozygosity with knowledge of the difference of what different allele combinations do in psilocybin mushrooms. And look, I'm just going to add on, because Cosmic Kaleidoscope's question was so good, I can just quickly say, from a perspective of magic mushroom growers who have the ability to produce them, every man and his dog can get an S9 license for research to produce psilocybin, to produce mushrooms that contain psilocybin. The problem is that the companies that are doing it, and there are many in Queensland alone, I know of several. In New South Wales, there's at least one. In WA, of course, there's one. The question is where do all the mushrooms go after they're produced? Because there is no supply chain. That's it for me.
Yeah, actually, that's a an interesting note because a lot of the justification for prohibition is around stopping big international criminal markets, and when things are growing in the lawns of sometimes police stations, you don't need a multinational criminal organisation to move things around. Just putting that out there. Caine? Wait, have you done one yet? No, you're our final 5 years. What do you want to see?
Oh wow, Alistair and Simon have both really answered that quite well already. Look, I would like to see a lot more easy access to psilocybin for mental health. Yeah, and I agree with Simon. I think it's, you know, why leave it so long down the treatment path till we actually have access to it, when, you know, a nice couple of trips can really help you work it out in your head, like what's going on, and bring up things that are worth talking to your therapist about. I would definitely also like to see a stronger push on decriminalisation. You know, the fact that there are so many people out there who do forage and who do just want to grow for the citizen science and their own experimentation. You know, and they're not doing anything harmful to anybody else. You know, it would just be nice to see, yeah, decriminalisation in that space, so that you know, people are not being punished for that. It would be really nice to have a more ready access to being able to kind of grow these in a research environment, as per like Alistair's comment as well. You know, like there are so many amazing cultivators out there in the underground, and their knowledge is not being taken advantage of. And it would be nice to be able to see a lot of those people be able to kind of come up from the underground into an environment where they can really show off their knowledge and their expertise in this space, and help create mushrooms that can contribute to this growing demand for tryptamines. So, and on that, I would also like to, you know, hopefully that the wood lover paralysis thing can be solved in a short period of time as well, because I certainly see a couple of species that are going to go by the wayside, and I think Psilocybe spruiginosa being one of those. You know, the novel tryptamines that it's suggested that they produce, and probably produce in higher amounts than other Psilocybe species. It would be nice to be able to see those entering this research space as companies get S9 licenses and are experimenting with cultivation and breeding.
Thank you, Caine. Thank you, Alistair. And thank you, Simon, for joining us on tonight's EGA webcast. A little early for mushrooms, although so are mushrooms at the moment. With all that rain and heat and humidity, there has been a wide variety of fungi growing in all sorts of places, including places you don't want, or at least I didn't want when I discovered mushrooms growing in weird places. Actually, the oddest place I've ever seen them grow out of is years ago I had a punching bag, and it's a variety I can't remember the name of now, but they were silver and kind of like conical, like that shaped, and sitting in my garage, these strange silver mushrooms bloomed out of this punching bag. Yeah, that was surprising, but a little bit of fun. Thanks, guys. Really appreciate it. Make sure that you do sign up for updates on the EGA website. And thank you very much to everyone who has joined us tonight. I was hoping to get away from this webcam for a while, but you know, just when you think you've got all the dongles you need one more dongle. And you know, I'm a hoarder of cables, as I'm sure there might be some other hoarders of cables in the section comment section here. If you are, dob yourself in. And you never quite have the right one, although I did learn my lesson once when I did go and throw out some, thinking that I've got to stop this cable hoarding. And wouldn't you know it, a couple of weeks later, I ran into an old device that I needed to access, no longer had the cable. Don't throw out your cables, just organize them better. That's my advice. And also just, again, reflecting that advice from Simon, fantastic advice. If you want to see change, what you do for change in a democracy is get involved with it. You don't, even if you're frustrated, don't hide away from it, because that's not how things get changed. It's how dickheads get in charge of things. I'll say that lightly, but I didn't. because that's what happens. That's what happens, and then terrible things happen because dickheads have a tendency for dickheadedry, which is a condition that they cannot escape, apparently. So you might have noticed it out there in the wild yourself. Thanks, guys. I'm going to leave you with this video from Liam. Liam doing something to do with cactus. He's always doing something to do with cactus. Let's have a look. Good night.
Hi guys, I'm Patrick Noll. They are like threatened in the way that people hack them down every year.
Yeah.
Like they're threatened in the way that they will not expand further because people pick the seeds. Like people take them down and keep them. Like a lot of the seeds do not end up like in the nearby area, which is a problem in itself. But these are so common plants for the natives that this is not a concern for them. And yeah, but they are not threatened. A lot of cacti are threatened. Also in Peru, like I said, Hageocerois, like these are they're relatively close to Trichocerois. They are threatened almost everywhere. Like every site, especially since this is a genus where you have like little species that only exist in one place and nowhere else, and they keep vanishing in an alarming speed. Probably also because of landscaping, like they are full of trash. People just build stuff on top of that. But yeah, like I wouldn't worry about like Pachanoi or Peruvianus just because they are so common, because people like to have them close. Like, but you constantly see big plants being cut back constantly. Like that large plant in Chavin.
Yeah, I saw those photos recently. Yeah.
Every 2 years you see a new one where they have cut it back, and it's just sad because this was such an impressive plant. This was huge. And yeah, it's not directly threatening, but at some point, like maybe in 100 years, you will lose some of these plants because they no longer like spread the seeds in the nearby area, like 100 meters around it. And yeah, at some point they will become less and less unless they do something. I mean, right now there's a lot of progress made, like especially with like poaching in habitat and stuff like this. And I suspect this is a thing that will be solved in the future. But for many cacti, especially the rarer ones, it will be too late. Like Hageocerois, I'm sure some of them will become extinct in the next 30, 40 years. And the same problem exists with Lophophora. You have a few very unique populations that we will lose. Like I'm sure at some point they can be reintroduced, like from like nursery grown specimens, but the original wild populations of many plants will be lost. It's just it's mostly due to landscaping. It's not. I mean, you have a huge problem with poaching on Lophophora, but aside from this and maybe Ariocarpus and these classic species, most of the other cacti are like become extinct because they are not valued. Like, seen some photos full of trash and it breaks my heart.
Yeah, it's sad, right? You know, there's the debate over what to do around threatened peyote. And it's like people saying that they shouldn't be replanting efforts, you know, like we shouldn't interfere with the original population.
I mean, what else can they do? Like, I mean, what's the alternative? If the alternative is that the plant just becomes extinct, then it's not an alternative, you know, because you have like these populations, like when you make sure you pick the right specimen to reintroduce, and you make sure that they survive for like 100 years, then you can get this thing going again. You know, I mean, you need to do a lot more for protection in habitat. Like it's the same with all these amazing animals that get lost, that get slaughtered, like elephants and everything. you need to treat poachers like with the harshest penalties that you have. And unless that happens, nothing will change. Nothing will change. You can reintroduce them, but you need to like guard these populations. You need to make sure they are not picked up again like 2 years later. And I don't think it makes sense unless you have a plan to keep them alive long term.